So today I'll be talking to you about career options and opportunities, software engineering. So I'll be covering various topics. Say like I will start with the higher studies, both in India and abroad. Then I'll talk to you, about the job opportunities in academics and research. Then I'll tell you about different type of industries. Then I'll explain you in detail how a product is developed. That's called product development flow. Then I'll tell you a bit on, PCB design flow and at a very high level on the IC design flow. Okay, and then I'll tell you about a different type of jobs in industry. So, and what is the requirement for each of the type of jobs? Okay, and later I will focus a bit on the interviews and the resume preparation, etc. How a good resume should look like, and how interview happens in an organization. Okay, so then later I will focus purely on the skill set that you need to have in your resume to get a job in core domain. Say starting from embedded system to signal processing to VLSI design and machine learning or AI and hardware design, etc. And then later I'll tell you, about the tools and components used in industry, in any type of industry. So it's very important for you to have some experience on that. And when you do your final year project and also many projects, you need to work on them actually. Really, if you want to get job in core domain in an industry, okay. So then. Later I will tell you a bit on the focus subjects then that you need to focus, and also at the end I'll tell you a bit on organization structure, etc., to make you aware of the organization and different department, etc. Okay, so a bit on myself. So I'm working with Philips since last 8+ years, and I have overall about 19 years of experience in electronics hardware design, mainly product design, you can say. So I work on various FPGAs, DSPs, and processors, etc. I developed quite a lot of medical products, and mainly in X-rays. Okay, so I also work in clinical chemistry and laser design. Okay, so a bit I work in automotive domain as well. Okay, so I work mainly in the hardware design, but I involved also in end-to-end product development, mainly in regulatory testing, reliability, and all of the aspects. So also I work in with various departments as part of my job, etc. Okay, so I've done my MTech in biomedical engineering and B in electronics and communication. So this is a bit on my, technical expertise and qualification. In addition to this, I was also part of the interview panel in Philips. So I've interviewed a lot of, people, mainly for technical roles. Okay, and in academics also I got quite good experience. So I'm external examiner for BE and ME in electronics and communication student for both Pune and Mumbai universities. And also when I'm working with some colleges on the curriculum developments, and also in conducting FTPs, and also the expert lectures, etc. So this is a bit on my overall experience. Okay, so I've told you what I'll be covering today. If you have any questions during this session, I mean, you can type in the chat box, or if you're not clear on certain things, you can type in the chat box. And at the end, maybe we'll have a 30-minute Q&A session. So that time I will answer each of those questions. Okay, and feel free to ask. So first and foremost thing for you when you are in third year, or at least in the beginning of final year, is to have a clear objective. Okay, so you have to really decide what you want to do. That's the most important aspect, because once you decide in which direction you want to go, or which domain or which technology you want to work, then you need to really prepare to that. That's very important. Okay, because in any interview if you're attending, whether it is a campus interview or off a campus interview, they will ask the questions about this. They will ask you about your objective, and also they'll ask questions like where do you see in next 3 years, 5 years, and so on. Okay, because this is a very important aspect actually, because then you need to know your interest. Okay, so when a company hires somebody, so they will see the interest of the person whom they are hiring. That's very important. Okay, so you have to select your field based on few things. So one is you can select it based on your passion and interest. That's very important. As you know, the career is quite long, say 20 years, 30 years, etc. So you should really like something what you do. So that's very important. And the second thing is the most important one. So you should select your field based on your skills and expertise. Okay, so that's the most important aspects. As you know, if you're going to work in an industry, it's always challenging to work in an industry, because you have project deadlines. Okay, so you have to complete your project in the given timeline. And the other thing is that you'll have to work on different technologies. Okay, so you'll have to work on different type of applications and so on. I mean, you may have to learn different things. For example, you may be doing a project say sometime in a DSP, and maybe later you may be doing it in FPGA, or sometime you'll be working on a processor. Okay, sometime you'll be programming it in a C language, sometime you'll have to use assembly language. It all depending on the requirement. Okay, so you should be having a good skill set, to learn this in a short span of time. That's very important, because you won't really get much training in an industry. Okay, so you'll be getting any training at a very high level actually. Then it's your talent and the knowledge, so that will help you, to implement those things actually. Okay, in the given time. So that's very important. So once identify your field of interest, you need to see whether you have the right skill set to work in that domain. Okay, and if you don't have the right skill set, you need to really build up on it. Okay, that's very important. Assume that you want to work in signal processing, so then you need to have very good knowledge on signal processing fundamentals, and also you should have good programming skills, and also you should have good knowledge on the the architecture of DSPs and processors and FPGAs, etc. Because all of the things uses to implement a signal or image processing algorithm. So that's very important. So so I'll be telling you all the things, in this my session. So you should really assess yourself. So the basic here is, you have to do a self assessment of yourself, and you have to see like what are the gaps, or what are your the areas where you are weak. Okay, so you need to really improve on that actually, because once you join an industry, you really don't have any time, because you have a deadline, so you need to meet. There is no way actually. So that's how it industry works. Okay, especially R&D. And the third thing is that you have to always look into the availability of job, in your field of interest. That's very important. Okay, because you should have sufficient opportunities, because as if you're working in a private industries, I'll frequently change the job and other things due to multiple reasons. Okay, so you should always have options. Otherwise it'll be difficult for you. And the last thing is that always you have to look for long-term career opportunities. When I say long-term career opportunity, so your career growth purely depending on the knowledge that you have, and also the experience, and also the projects that you have done. Okay, so your growth purely depending on that. Okay, and your salary is defined by your skill set. Okay, not purely defined by the experience. And that is also the reason why VLSI engineers are paid high, or even signal processing engineers are paid much higher than a normal embedded software engineer. Okay, so so your aim should be to work in a core domain, and to do on latest technology, and good projects, etc. So that is only the going to help you in long term career plan growth. Okay, so what I mean to say here is that don't look for the salary as a fresher. Your aim should be to work on a lot of technologies in first 5 years of your career, and that's going to define your future. Okay, so there are a lot of companies. Okay, so there are a lot of companies in core domain. If you say to be precisely, you have over 2000 companies in India working in core domain. You can Google it, you'll find a lot of them. I mean, there are many small companies, startups, and so on actually. So they work on different technologies. Okay, so only you have to find it, and and most of them will not be coming for campus interview, because they will do off campus. So you can try it and you can get it actually. So that's the way you should follow. And your aim should be always to work on the technology, not you never look the salary as a fresher. Okay, don't run behind the salary, and also don't run behind the company's reputation. It's your work that's going to define your career. It's not the company where you work. Okay, so please understand these aspects. Okay, so with this I will start the session. Software engineering, you have different options. So you could go for higher studies. So I'll tell you about that soon. Or you can go for job. It can be in industry, or in academics, or research, or you can start your own company. So higher studies, you have a different options. So one, you can go for MBA. I will tell you where MBA is useful. It's not useful if you want to work in R&D. Okay, I'll tell you where it is useful later. And now you can go for MTech after your engineering. Okay, so I'd like to tell you a few things here. First, really need to have an objective. You need to know what you want to do. Okay, and accordingly you have to choose your specialization. Suppose you're not interested in R&D. There are a lot of different type of jobs in industry. If you're not interested in R&D, so you could and if you're interested in certain things, for example sales, marketing, etc., you could do MBA, for example. Okay, so that's why I told you need to have a clear objective. So blindly you should not join for any course. You should know what you want to do, and accordingly you have to choose your the course, and also the specialization. Okay, so that's the most important thing. And having ME MTech is highly beneficial in industry, because MTech is considered as 2 year experience in industry. So if you have MTech, you'll be joining at a senior level, and you'll be paid high actually. And even in your for your career growth, having masters is always beneficial. And that is the reason why even Manipal, or say Bits Pilani, etc., have started work learning program, work learning MTech programs. So that's for people working in industry. Okay, so in industry always look into people with a master's degree, when they once you grow in your career, because they always want people with more skills, and qualification actually. So that's always going to help actually. Okay, if you have that. So whatever 2 year you are going to spend, that will get you a huge return of investment. So you have to understand that. And if you are interested in academics or research, you could do PhD, and further you could go for postdoctoral research if you really want to work in research or in academics. So you have a lot of options in India as well as in abroad. Okay, so those are typically 1 or 2 year fellowship depending on universities. Okay, so now I'll tell you on higher studies in India. So to get admission in ME or MTech, you need to have a good gate score. So that means you need to prepare from third year onwards, because you need to have at least 90 percentile actually. Otherwise, you won't get admission in good institute. Okay. So you have a different type of master's degree like ME, MTech. Those are conventional master degree where you have a lot of theory subjects, and also you have practicals, etc. Then you have a research master's degree like MS or MSc engineering or MTech, where the focus is mostly on research problem or research dissertation, etc. Both are good. I mean, industry or academics give preference to both. I mean, there is no differentiation at all. Okay, so again, if you see electronics, you have a lot of specialization there. So as I told in the beginning, you need to have a clear objective. You need to know what you want to do really. So your specialization should be purely based on that. Okay, so you need to know the syllabus of each of these courses, so that you can find from university website or college websites. Because if you see, for example, any of these branches like a VLSA or embedded system, the syllabus vary from university to university, so you need to know what you will be studying there. So that is the first thing you need to see, like you need to go through the syllabus. Okay, so that should be the first factor you need to consider. Second thing is that you need to also consider the facilities available in the college, like lab infrastructure, the tools, and also the professors, etc., because these things are very important when you're doing master's degree. Because you need to have the right tools actually. For example, you want to work in VLSA design, then I mean you can do MTech in VLSA, but then you have to ensure your college also has the right tools actually there, because tools and software, because otherwise it will not really help you actually. Because once you do MTech, the industry also expect you have got a certain experience on those tools actually, because they want that you'll able to work from the day one actually. So that's what industry also always expect. Okay, so if you're interested in a signal processing or communication, you could choose signal processing, or general embedded system, you could choose embedded system. There are a lot of branches like electronics product design. It's there in, for example, in NILT in Calicut, or even NIT Calicut, and so on. So that's purely for hardware design. So a lot of specialization. So you can go through the syllabus. I mean, in various universities. So accordingly, you can choose your field. Okay. So this is about the higher studies in India. So you could also do master's degree in abroad, in America or in Europe or in Asia Pacific countries. So I've considered all these countries based on the job availability in core electronics field. Okay. So again, if you want to do master's degree in abroad, you need to prepare from third year. The reason is that one is that you have to prepare for IELTS, TOEFL, etc. And if you're going to US, you need to prepare for GRE. So, but that is the minimum requirement you need to have. Okay. The most important thing is, like all these universities will look into your final year project, and also they will see whether you have published some papers in reputed journals. Okay. So that's very important, and that is going to decide your admission, and also that decide your scholarship. Okay, so so what I mean to say here is that you should do some good projects. You should have some paper published in reputable journals like IEEE, etc. So that is going to get you admission in the universities in abroad. Okay, and that's also going to help you to get a scholarship. Otherwise, the problem is that master degree in abroad is extremely expensive. It could go say 30 to 50 lakhs for 2 year program in any of these countries. Okay, so you need to get scholarship. So you need to really have good papers published and so on. Okay, so that's very important. And that's one aspect. Another thing is that in whichever country you're going, first you need to, like, you have to choose your specialization based on your objective. Second thing is that you have to also study the job opportunity available in that particular country. That's very important. Okay, so I mean, if you, for example, you want to work, say, signal processing, so you need to ensure that the country has a lot of companies working on that. I mean, otherwise, what happens is that after your master's degree, you will maximum have a 1 year visa left. Okay, and if you don't get job within that time, you'll have to return back to India, and then when you try for a job, you are equally paid like an MTech. Please understand this fact. Okay, so we have a lot of people with MS from US, I mean Germany and Belgium, and UK and all, like, so they are equally paid as MTech in India. So you have to understand this fact actually. So you need to really study, I mean, the job market in that country if you really want to work in industry. Okay, so that without that, blindly you should not go any country. So you should do a basic research, understand like what are the opportunities available, and also you need to have a right skill set actually to get the job. Okay, because otherwise you'll have a huge financial loss actually. Okay. And you can find a lot of information on the universities and admission and other things from study portals. This is the best site. It's a Netherlands based site. Actually, there are a lot of sites like for master portal, PhD, and so on, even scholarship and so on. You can refer it, okay, if you want to go for higher studies in abroad. And find master is also a good site. So please really study the job market in the country. I mean, don't just believe in the agents, because that's why I will not consider New Zealand is not a place for electronics engineers. Okay, I mean, because you have to really have opportunities in that country, otherwise it won't really make sense. I mean, I mean, to go in that country and spend the money and to do a masters. Okay, so you have to do a proper analysis. That's the most important thing. Okay, and then you have to choose that country. Okay, and you can contact the professors when you are in final year itself, because typically in most of the countries, the admission is decided by the professors actually. And so if you're working in certain domain, you can search and you can find a lot of universities, and then connect with them actually, and so that will help you also to get admission. And also I mean, they could guide you, to on certain things which you need to work, and so on actually. Okay, so that's very important. And Europe is a good option, because you study in Europe, you can work in other countries in European Union. Europe has got plenty of industries in any domain you take. Okay, so this is a bit on the higher studies. So now I'll tell you about career in academic and research. So if you're interested in teaching, so you have to do MTech if you want to get job as assistant professor in engineering college. Okay. Or if you're interested in research, you could join as a research associate or fellow in various colleges and universities. Okay, so then later you can do MTech, or you can go to industry actually, because I mean, even research associate positions are also considered as a good position. I mean, a good experience. For jobs in industry, because you'll be working on certain research problem, and you'll be developing certain things, so that will really help you to get job in industry at later stage. Okay. So now I'll tell you about industry types. So it's very important for you to know these things. I'm sure that everybody will be aware of IT companies. So what typically IT service companies does is that they develop products. I mean, not products. I would say they develop a part of the product development for their customers. So like for various companies. Okay. So they do different type of work. They work on core electronics also. Say wheelers design, or signal posing. For example, we pro in Kochi work on wheeler design, or in Tata Elxsi in Trivandrum work on signal posing or image processing and so on, right? So they do different type of project. They do testing, they do quality type of activities, and also they do infrastructure, financial, or banking type of software development, etc. Okay, but you have to understand one thing: only less than 5% of the students who are recruited from campus will get a chance to work in core domain. Okay, so to get in core domain, you need to have a really good skill set in your resume. Okay, so what typically these companies does is that once you join the company, so they will ask you to submit your resume, and they will see your resume, and they will be based on the skill set, they will decide in which team to, or which type of project to put actually. Okay, and assume you're not selected in core domain initially, then you will not have any chance to work on core domain. Please understand this thing. So my advice to final year student is that once you get an offer from any company, please don't stop studying. You need to have right skill set if you want to work in core domain. Okay, because that's the biggest mistake most of the time students are making actually. So they're just assuming that, I mean, I need not do study anything. I mean, and that's end. So I got a job, and so I can start working. That's not true actually, because your profile is not fixed actually. Because they could put you in quality testing or anything actually. It's your skill set that's going to help you, to decide them, to put you in your field of interest. Okay. So that's very important to know. Then you have product companies like Eaton, Honeywell, GE, or Philips. So all these companies, we do product development. We design the product, develop it, and then manufacture it, sell it, service it, and we support the customers, throughout the product life cycle. Okay. So these are the best companies really to work, because you get a lot of learning opportunities. Okay. Then you have electronics manufacturing service companies like Jabel Flextronics and Sanmina, and even we have SFO in Kochi, for example. The main activity what electronics manufacturing service company does is that they manufacture the products for the product companies, and also so mainly they do PCB assembly, testing, etc. And also sometimes they do a module assembly or even complete manufacturing. Yeah? So it will be outsourced to these companies. So they will do these activities, and then they will do extensive testing actually. To meet all the quality requirements actually, and same time they'll also do design activities. So these are also really good companies to work. Okay, because you get really good exposure there. Then you have a semiconductor companies like TA, Analog Device, or Sarin. So whichever semiconductor manufacturer you take, almost 90% of them have R&D centers in India. Okay. So TA and all has got a huge R&D center, with over 3,000 engineers in Bangalore. I mean, so then this is really the toughest, job to get and the highest paid also. Okay, so what typically they do, they design the ICs, okay, and also they develop a lot of algorithms and softwares, and also they develop the software development tools. For example, Code Composer Studio or Visual DSP for DSP and so on, okay, or even the Xilinx ISE, and also that's done at the Xilinx in Hyderabad, for example. So these companies does all these activities, and so the selection procedure is extremely difficult to really to get a job there. Then you have product certification companies like ULTV, etc. So if you look into your laptop charger, you can see a lot of marking like CE, UL, and so on, right? So if you want to sell a product anywhere in the world, okay, so you need to get some regulatory certifications actually, without which you'll not be allowed to ship your products. Okay, so CE marking is for the European Union. Okay, so to get these certifications, these companies will do a lot of testing. They do regulatory testing. Okay, they, I mean, like AMIMC, and then do safety testing. They do environment testing to ensure your product is meeting all the regulatory requirements for that particular country. Okay, so once your product meets, you can start manufacturing a product and ship it to their countries. Okay, so these certification companies will help in all these things. So for example, ULTV, all are then in Bangalore. They have got the labs, and also in central government we have a Samir in Chennai or in Mumbai. So the way there also they do all this type of testing, EMIMC testing. Then you have a government organization like ISRO, DRDO, and all. So typically to get job here, you need to have a good gate score. Okay, and these are also really good companies because they do a lot of research and development activities. Okay, and then you have other government organizations like Navy, or Indian Oil Corporation, or Railway, or BSNL, etc. So you can also get job there, but there is no design activity there. This is just integration, maintenance, testing, and servicing, and so on. Okay, so you have to understand this fact actually. For example, if you work in these type of companies, and in more than 2 years, you will never able to come back to R&D because you won't be considered in R&D. Okay, so you have to understand that. Okay, so now I'll tell you about the product development flow. How a product is developed. So it's very important for you to know all jobs in an industry for an engineer. It's around this actually. So you've got say from from R&D to sales and marketing. Okay. So so in product development, you have a different stages actually. You start a project, then you do a design, then you do testing, and then it's a maintenance stage. Okay, after manufacturing, you have to maintain it. Actually, means you have to do servicing, you have to update the products, or if any issues there, you have to repair and so on. Okay, and if you see like there's the entire product element flow is done only in a product company. Okay, IT companies does say like maybe design or sometime testing and some part of it actually, roughly 30% of it. Okay, so that's the reason why I told you. If you work in a product company, you get a chance to work in every aspect of it because you need to know why you are doing a design in certain way. So you need to know the history behind it actually. So that exposure you'll get only when you are working in a product company. And from long-term career growth, it's very important for you to work in a product company. Okay, so IT companies are for only for short-term career. Because they do some design and then they give to customers. So then you don't know what is the next, what happens next actually, because you need to really know actually, because that's how you are learning actually. Because you will always learn from your mistakes, right? Whichever company make a product, always there will be certain issues, and that's why we are always improving the design. It's a continuous improvement activity, right? So in product initiation, you decide to to start your product development. So you have two different type of products. So one is like a new product development, so where you'll be developing a product for the first time. And other case is like you're developing a next version of a product, or in automotive industry typically it's called a facelift version of a car, for example. Okay, so why you want to do facelift version or the next version of product? There are multiple reasons. One is that once you launch a product, you'll always have certain issues. Okay, so it could be a design issues. Okay, or you might have not considered certain aspects actually, or it could be customer misuse. So whenever you have any complaint, for example in your car, you take your car to service center. So they do analyze what the issues, and then they will repair it. Okay, so typically all the car manufacturers, so they take the feedback from all the service center across India or anywhere, on periodic basis. They get all the information actually, what are the failures and what if part is changed and why it happened, and so on. Okay, so they will study all these failures, because it's very important for you to understand why something failed actually. Okay, so you have to find the root cause, and then you have to improve your design if it is a design issue. Okay, so that is the one major factor, because if you don't fix it permanently, that will have a big impact on the company. For example, it will affect your brand reputation, and also it will affect your market share, and also you'll have huge financial loss, because you will to bear the warranty cost. Okay, so that's one aspect. Another aspect is that if these problems are causing any safety issues, okay, like if airbag is not deploying, for example, okay, so that will cause big problem to these companies, because they have to pay huge fine to the government, and also to the customers, and also it'll also call for stopping the production actually. So that'll have a big impact actually. Okay, so that's why we have to identify, whenever you have any failure, okay, so the company will always look into these issues, why it happened actually, because you have to really do a root cause analysis. Okay, so then you have to improve your design. That's one thing. The second thing is that when you launch a product, you will launch with certain features. At the same time, you will have a lot of competitors. They will also come up with a different products. Okay, so some of them will have even better features. Okay, so mostly the features also will impact the sales actually. So a product which has a better features will always have a better market share, for example. So you need to really study actually how the market is moving, what are the features the other competitors are having. So always the sales and marketing engineers in a company do this type of analysis. Okay, and so then that they will bring to the management of the company. Okay, so like the competitors are in these features, and that's why their sales is going up, for example. Okay, so that's very important. So that's called a feature enhancement. So when you want to add any new feature, again it's a redesign. It can be a software change, or it can be hardware or even a mechanical change, for example. Okay, and the third thing is that when you develop a product, and over a period of time, you have to reduce the cost of the product actually, because you can reduce the cost of the product by optimizing your design. That's one aspect. Another thing is that you have to integrate many of the components together in such a way that that will help you to reduce the assembly cost of your product, and also it will help to reduce the size of your, let's say, PCBs and other things. Okay, so that will directly affect say the cost reduction actually, and that's called the value engineering. So these are the three things when any company, when they're going for a next version or a facelift version of a product, will be considered. Okay, whereas you are going for a new product element, you need to really study the market. So the marketing and sales engineers will do customer survey to understand what are the expectations from the customer for a similar product, what features they expect, and also they will study the other products, similar products in the market from competitors. What are their features, how is the market response, what are the complaints and all other things, because you need to know all those things, because you need to understand also the failures, right? Because that's very important, because that will help you to prevent those things in your design. Okay, so these are the things you will consider. Okay, so once that is done, you have a lot of data with you. So with that, you can define the concept. Okay, so there you will have to do a technical feasibility also, because you're going to implement something new which you have not done before. So you have to do technical feasibility, whether it is possible for you to implement it, okay, technically, and also possible for you to implement in a given time and cost, because time to market and cost is very important factor. Okay, so that's why you have to consider that aspect. Okay, so once you have that concept, okay, at a high level you will decide, okay, this is how my product will look like, and these are the major building blocks of the product. Okay, once that is done, you will also define your specification actually, because that's very important, because your design starts from there actually, because you need to have a specification. Okay, so you need to know what are your inputs, what are the output. Okay, so that's how do you typically, and what are the features your product will be offering to the customers. Okay, so once that is done, you will reach this stage where is the your design specification, system design. This is where you define your detailed architecture of your product. Let us consider car audio system as an example. So in car audio system, we have got different components. For example, you have a processor. So you have a speakers, amplifiers. You have a lot of Wi-Fi modules and Bluetooth modules, and also you have got a display and touchpad interface and so on, right? So you will identify those building blocks, the first level, and the next level is that you have to finalize, the which technology, which type of LCD you'll be using, which type of speaker you will be using, and also which type of processor you will be using, because that's a main factor here, because you could use a DSP, or you could have your own ASIC, or you can use an FPG and develop. Okay, so that is something which you have to decide actually, because you have to do a lot of analysis. You have to consider always when you define your high level architecture, can we upgrade it in the future if we need it? For example, you are designing a car audio. So the car audio, should always support at a higher power output actually. So when you design, you should have an option to configure for a higher output actually. So you, if you take an automotive company, say like Bosch or Continental, etc., see they develop all these products for different car manufacturers. Same, they will be developing for Hyundai, and they will be developing for Audi or BMW. Okay, so they will develop a product in such a way that it is configurable for different customers. Okay, so for example, you need to have a memory, so it should be configurable. For example, you're the DSP should support different memory sizes. Then only we'll able to design that it for different customers. Otherwise, you'll have to completely redesign it actually, and that's very expensive. So that's very important actually. So you have to, it's called a platform architecture. You have to always think in that future. You have to see whether my design support all future requirements actually. Okay, and at the same time you have to consider the cost also. So typically what company does is that they will have two variants of product. One is for high-end products. Okay, so it's for luxury, car makers, and then other will be for the low-cost car manufacturers, so for example. So it will be different type of it. Okay, so whenever they develop any product, with us minor changes, they can support other customers. Okay, that's how the goal it should be. Okay, so here also you'll be doing a lot of analysis. You will see whether your processes support for future requirement and so on actually. That's very important. So once you have done that actually, then you'll go for a detailed design. Okay, so there you will split your team. If you take a car audio, you have different activities. You'll have electronics and hardware engineers, so they will be designing the circuits. Okay, and then they will do the PCB. That's the layout of the, sorry, circuit simulation, and also then PCB layout, etc. Okay, and then they get the prototype. Same way, you'll have a software engineer. So you'll have a different type of software engineers here. So somebody will be working on say signal processing algorithms, and somebody will be working on the communication module interface software development, and somebody will be working on the user interface and other things. Okay, so initially, if you assume, if you're developing for the first time, so you will not have any hardware ready. So software team will work on the evaluation boards. Okay, so then they will develop the software there, and once the hardware is there, they will integrate it and they will do the testing. Okay, so the testing is very critical. So the first level testing will be done by the design engineers themselves. So they will do extensive testing to identify the problems in your design. Okay, so if you have errors in the software, yes, you can correct it easily. But if you have errors in the hardware, then you may have to redesign the PCBs and so on. So that's again a time consuming activity and cost also, because so you'll have to again come back here and you have to follow the same process. Okay, so once the testing is done, by the designer, so then you'll go to formal testing stage. Okay, so in every company will have a separate testing and verification team. So there will be a lot of engineers there. So their job is to test the product. So they will develop a test softwares, protocols, or also even the automation setup, etc., to test the product. Okay, so they will do extensive testing. On different aspects of the product. They will see whether the product is functioning as per the requirement, and they will continuously run the say your system for example many days, and they will monitor actually. So you'll monitor a lot of signals and the voltages and so on. They will see how it is varying, how is the temperature of the components in the system, because these are the very important aspects actually. You need to always check. Okay, so they will again record all those things. Okay, and if there are any issues there, then R&D design engineers will analyze why this happened, and whether there are any issues in the design and so on. And if there are any issues, they will again redesign it actually, because without that you can't proceed further. Okay, so the testing stage is to identify the errors actually, or so something which you need to really improve. Okay, so in testing, you have a different type of activities. So first is like the for the testing and verification will be done by the testing team, and then you will have a reliability testing and environmental testing, and finally you will have to go for a regulatory testing. That's for getting the certification of your product. Okay, so reliability test is most important test. So the purpose of doing a reliability test is to identify early failures in your system. Okay, because you need to really understand what all things can fail in your system, whether there can be any problem in the hardware or in the software and so on. Okay, so those are very important actually. So in reliability, what typically we do extensive temperature testing, temperature variation testing. Also you do testing at a different humidity levels, and then you do vibration tests, etc. Okay, so I'll tell you each of them. So the temperature variation test, typically what we do is that assume your system operating temperature is say 10 to 50 degree. You may test your system say at maybe minus 20 degree to say 90 degree, and you will monitor the performance of your system. You will monitor a lot of signals during the test. You will keep your system say at 10 degree, and you will operate it, and you will see how is the signal quality, and the performance of your system. Okay, and at a different temperature, you may test at 30 degree, or you may test at 70 degree and 90 degree, and so on. Okay, and you will monitor the variations in that. Okay, that's one aspect. Another thing is that you do a temperature variation test. Okay, depending on type of products. So you will vary the temperature, say maybe 10 degree in 1 minute or something like that, and you will increase the temperature from -20 to say 790 degree, in 10 degree per minute actually, in that way. And then you will monitor the performance of your system, and also the signal levels actually, how it behaves. Okay, so this is very important. Same way, you will also decrease the temperature from high to low actually, and you will see. Okay, as you know, any electronic components performance affect with the temperature. So your resistor value will change with temperature, your offset voltage in an op amp will change with temperature, and also your this nonlinearity errors in the analog to digital converter or digital to analog converter also changes with temperature. Okay, so that's one aspect, and that will affect the performance or even operation of your system. So you have to fix that. That's one thing. Second thing is that the ambient temperature has a direct impact on the power consumption of your system. Okay, so, and if the ambient temperature is high, it will cause power dissipation, and then that will cause heat on the devices, and that if the device is getting for example your ICs are getting hot, that will affect the reliability of the products. IC may fail it soon. Okay, so you need to have a good heat sink and cooling mechanism, etc. So that's very important actually, because otherwise IC will fail fast actually. Okay, and that will cause a product failure itself. Okay, so by doing this test, you will understand what are the problems in your design, so you'll have to fix it. So what typically you do is at the first level you will try to see whether hardware how much you can do. I mean, for example, you can select a component with a low thermal drift, or maybe with low offset voltage, or maybe you can select a component with a lesser tolerance. So it will help you at certain extent, but that's not the permanent solution, because that will not help you really to avoid these variations, because these variations will impact the performance of your system itself actually. Okay, so ideally, I mean, your system should function in a similar way at 10 degree or at 50 degree. Okay, so there should not be any variation in the performance. Okay, so other thing is that we will correct these errors in the software. Okay, software. So we will have a certain software algorithm where you monitor the temperature, and accordingly you do error correction. Actually, there are a lot of algorithms will be developed by software engineers. That is also one of the reason that any embedded software engineer working in R&D need to have good knowledge on electronics. Without that, you can't develop an algorithm. Okay, because you need to know the behavior of your component in different conditions. Okay, different environment conditions, you need to correct them actually dynamically. Okay, so it's very important. Okay, so that's about temperature. The humidity variation will cause a condensation, so condensation will cause say short circuit in any product. I mean, okay, so you'll have to avoid that actually. So you'll get to know about this actually during this test. And vibration test will help you to understand how your components are assembled, or the PCBs are assembled in the system, and how good the cables and connectors are actually. Because what happens is that in vibration test, sometime your PCB may come out, or even your connectors may come out actually, and that will cause system will not be functional, etc. Okay, so you have to accordingly you have to select a connector maybe with good locking mechanism, or you may have to have some gluing, or some clamps and other things, so that in vibration it will not come out actually. Okay, so all these things will help you to understand the issues in your design. Okay, so that's very important, because you need to always identify like what are the weakest you know link, or with the weakest component that's going to fail faster, then you have to replace it actually. Because in the field it'll fail over a period of time, so you need to really identify all of them, and you need to fix in the design stage itself. Okay, so that's a final goal of a reliability testing. Okay, because if your product is not reliable, it has a lot of impact. One is your brand reputation will go, another is you'll have a huge financial loss, third thing is that if it is causing any safety issues, you will have to face a legal issues actually. Okay, then once this is done, you go for environmental testing, where you do testing of your system at a different temperature. Okay, so here the testing will be on the operating temperatures. Suppose when you say your system operates from 10 to 50 degree, you'll have to test your system at 10 degree, and maybe a normal ambient temperature that's a 30 degree, and maybe at 50 degree. Okay, and so then you'll have to see the performance of your system. Okay, so then you have to ensure that your system give us say similar performance actually in all this temperature range. Then similarly humidity you have to do a testing, and you have to ensure that there's no problem in the system. Okay, so once all these tests are done, and if it is passes, you will go for a regulatory testing. Okay, in the regulatory testing, what you do, you have been sorry, I mean you go for a certification testing. Okay, so there you do multiple things. You go for regulatory testing, then you go for safety testing, and finally the all the regulatory authorities also do environmental testing, because they have to be very sure like your system meets all the requirement actually based on the specification that you have defined, and also they will do a power measurement and other things actually. Okay, so that is also part of their activity. Okay, and so once all the tests are passed, they will give you the test report. With that, you can go for a certification, then you can submit these reports to the regulatory authorities in each country, and after the verification of that, you'll get the certification, and then you can manufacture the product. Okay, so in regulatory testing, typically what you do, you will do electromagnetic interference and compatibility test. Okay, so there you typically do two type of tests. So one is you will do the radiated emission test and also conducted emission test. Okay, so your system typically will emit electromagnetic waves. Okay, so it should be within certain limit, and also it will cause a lot of conducted emissions. Okay, so that will flow through your power supply and all, and that could cause a problem to other equipments also. So but the purpose of doing this test is to ensure your system is having a lowest possible the radiated emission or conductive emission for particular country. Okay, so that is where what we will be checking actually here. Okay, now if you have a say higher radiation level, so that could interfere other equipments actually, so that will cause a problem there. So it could even affect the brain, and or for example, if somebody is having pacemaker. Okay, so it could interfere the operation of pacemaker, and pacemaker will generate signal at different frequency, for example, and that could cause a person's death, for example. So that's what we have to ensure. Your radiated emission and conductive emission level is at lower side. Okay, so that's one thing. Another thing is that you have to also do immunity test to ensure your system is immune from external noises like conducted emissions and radiated emissions. Okay, so we'll emit all the radio electromagnetic waves, and also see how is the performance of your system, whether your system is getting interfered or not. So earlier when you had a CRT TV, and whenever you turn on your mixer grinder, you see a lot of lines, right? So that's called electromagnetic interference. Okay, so you have to ensure that your system is immune. Nowadays in your LCD TV or LED TV, you don't have these issues, right? Because it is a better design. That's the reason. Okay, so you have to always avoid this interference. Okay, so that's the thing. And also in general, your system should be immune to external interference, same way your system should not uh, you know cause any problem to other equipment. So that's the main goal of doing this testing. Okay, so you will do the testing, and if you have any issues, then you'll have to solve it. You maybe you'll have to have a better shielding, or maybe more filtering and different things actually, a lot of things. Okay, and next is a safety testing. The purpose of doing safety testing is to ensure your product is safe. Safe means it should not cause any shock to the user, and it should not catch fire, or it should not cause over temperature, for example, and that should not cause any burn. Okay, so suppose if user touches the cover of your TV, he should not get burned actually, for example. So what typically we do is that in this test, we typically monitor the performance of your system. So will turn on the system, will operate it, and then your first level you will monitor all the temperature, you'll measure the leakage current and so on actually, and you will see whether everything is within the specification. The next level, what they do is that they will make a fault condition actually. They will directly short circuit actually different parts in your design. Okay, and they will see what happens there. Okay, so it's a destructive test really. You will short circuit, and you will see what happens to your system. So if you do a short circuit, large current will flow, and that typically a fuse should blow. Okay, if your fuse is not blowing, for example, so that could cause fire, or it could cause even our temperature actually. Okay, so that means your systems fail there. Okay, so that's why in every system we'll have fuses, and it's very important for you to select the right fuse at right rating. Okay, so that's important aspect. Another thing is that you should also have thermal fuses. Sometimes what happens, when you do a short circuit, I mean, fuse may not blow because the current may not be so high, but actually that will cause a temperature rise actually, and that could affect a person as well, when he touches. So you need to have a thermal fuses, so that will get open, and so there will not be any power to that. So you'll be checking all these things, okay? So they will make a lot of fault conditions, and they will see how your system behaves actually, whether it's causing any problem, okay? So once it's everything is okay, I mean, your test is passed, and then the next level they do environmental testing to check your system is operating all the conditions, okay? And if everything is fine, you get a report. With that you can approach regulatory bodies, and then you will get a certification, okay? Once you get certification, you are ready to manufacture your product. So in manufacturing, you have a lot of activities involved. So first thing is that any product you take, it's made up of different components, and the components are coming from different supplier. So in a factory, you will have a procurement or supply chain engineer. They are electronics engineers. So they will, work with various suppliers in getting the components on time and continuously. And also they will discuss with them on negotiation actually, because you'll be purchasing, so you need to get the right price. That's very important. Okay. So once the part comes to the factory, there will be a quality department. They will do incoming quality check of the parts. So they will look into the test results, test reports of the products, and also they do a visual inspection to see there are any damage. Okay. And sometime depending on the type of components, they may even do testing actually. There will be testing, and they will test these products, okay? And once it is screened there in the quality department, it will go to assembly, okay? So there your product will be assembled, okay? And once it's assembled, you'll go move to testing stage, okay? So there you'll do a detailed testing of your product. So whatever product manufacturing, it has to undergo a lot of testing actually. You'll have to do certain testing, like a leakage current measurement, and also the power consumption measurement, and certain you'll have to monitor certain signals, and also you need to look into the performance and all actually. So there will be extensive testing there happening. So some of the testing will be automated, and some will be manual, and so on, okay? So you need to have also the record of all these tests actually, for example. Okay, so once it's done, quality team will look into the final test results and the reports, and if everything is okay, they will allow the product to be shipped from the factory. Okay, once the product is shipped, it will go to the customer. So there are different type of products. So you for example, you buy a mobile phone, you can buy from any shop, and you can use it directly. Okay, immediately after you bought it. Okay, whereas you buy a communication equipment or a medical say imaging system, for example, you can't use it directly. The reason is that we'll be say when shipping the product in different boxes, for example, because it will be shipped as a different parts actually. And once it is reached to the customer, then the service engineer visit, and they will integrate all of them, and they will do the calibration, and then it will be handed over to the customer. Okay, so if the product is new to the customer, then there will be application engineer who will visit there. He will give a training to the user how to use the products. Okay. Okay, so once the product training is over, the customer will start using the system, the complex system, I would say. Okay, so once you start using the system, and if you face any issues, you will either call the customer care, and then service engineer will visit. Or if it is a vehicle, for example, typically you take it to a service center, they do the service. Okay, so periodically, the product manufacturer will always get the feedback from the say the service centers or the customer care department, and then they will look into the issues to understand why the part is failing, what is the main problem, and so on actually, because you have to always understand the root cause, because you need to fix it permanently. So again, R&D here, a lot of people will be involved. You'll have a manufacturing engineers, you'll have a service engineers, and R&D engineers will be involved there, because sometimes it could be a manufacturing issue. Sometimes it could be problem in the product, or it could be a design issue. So you need to really identify what is the exact root cause actually. Okay, and then if the issue is so severe, then you will have to redesign. Okay, so that's again the next version of your product. Okay, this is how a product is developed, and all type of jobs revolves around here. Okay, and it's a continuous activity. And if you want to be part of all this activity, you need to be in a product company, and that is where you get gain real knowledge. You need to know what happened to your product after it's in the market. That's how we learn. And probably why initially when this all German cars launched, for example, the BMW, Audi, and all, they failed quite badly in India, because they didn't consider a lot of things. Say for example, their tires are so soft that it get punctured so frequently. So then later they changed the design, because they didn't consider it for Indian market. So they didn't consider the road conditions and other things. Okay, so when you work on the end-to-end activity, you'll get a lot of experience and knowledge, and that's going to help you in long term. So that's the reason it's always good, to work in a product company. So you really know actually what happens. I mean, in your software, you design certain things. What could happen actually. Really, and why. And then later once you get a feedback, you will do a root cause analysis, and that will help you to improve your knowledge and also improve the design to help your company. So both way it will help you. One, it will help you technically. Okay, so your experience and knowledge will improve because you do a mistake. What is the impact, and so then next time you'll really consider all these aspects when you design. So this type of experience you won't get in an IT company. Okay. Yeah, this is a bit of a horizontal view. Same thing what I've told. So as I told start, then you do analysis, where you do feasibility, then you define the architecture, you design it, different design. Say circuit design, FPGA, firmware, and so on. Then you do extensive testing. Then you go for certification. Okay, then once that is done, you go for manufacturing, and a lot of testing will be done then, and then you ship the product to the customer. Customer start using it. Okay, and if he has any complaint, he'll raise I mean complaint, and accordingly he'll repair and solve the problems. Okay, and then you have to support actually throughout the product life cycle. For example, medical product, we need to support 15 years actually after you sell your product. Okay, so that's how the agreement is. So depending on type of products. Okay, so it's very important also for to support throughout that phase actually. Okay, so now I'll tell you quickly on PCB design flow. I mean, so PCB design flow start from the functional block diagram. See, once you define the architecture of any product, you have to identify the components. Say you have to identify which type of resistor you are going to use, capacitors or voltage regulators and so on. So once you identified all those components, so you'll have to next to design the schematic in a schematic capture tool. I'll tell you about the tools later. Once the schematic is done, you'll have to do simulation. That's very important. Okay, because you have to ensure your circuit works actually as per the expectation. Because if there are any errors in the PCB circuit, okay, so you'll have to redesign the PCB. So it's very important here. Okay, so once the simulation results are good, I mean, then you have to move to layout. In the layout, the first thing is that you have to place the components. So once you place the components, you have to ensure that the placement is fine, because if the placement is not good, so what can happen is that the components may interfere with each other. Okay, so you have to avoid this interference actually, because that will affect the performance of your system, and it will cause a but it will cause a it will cause a problem actually. So it is very important to do simulation to understand this impact. Okay, because sometimes you will have a space constraint. So in that case you will have to have a good shielding and other thing, grounding, etc., to minimize this interference. So it's very important. And the next thing is that once this placement is finalized, the next thing is routing. Okay, so you have to connect all the components. Okay, so when you route it actually, so what happens is that you'll have different type of signals in the PCB. So you'll have a power signals, you'll have analog signals, clock signals, and so on. Okay, so sometimes what happens, you will not route it properly, and you may route a clock signal so close to amplifier input and output. Okay, so this clock signal will cause oscillations actually. So you need to avoid these things, because otherwise your system may not work, or you'll get have a output fluctuating or oscillating. Okay, so that will create problem. So you'll have to see do a simulation again to see the signal integrity, how the signals are interfering with each other and all. Okay, so there are tools actually for that. Okay, so once that is done, and then you can go for manufacturing and testing of PCBs. Okay, so I'll tell you at a high level on IC design, and then FEG design also. The front end is same. In IC design you have both front and back end. So in IC design, or in FEG design, the first step is to define the architecture. Okay, so you have to decide what you want to do. Okay, so I mean, you have to identify the building block of your IC actually. So if you take a microprocessor, you'll need to have a core, microprocessor core, different type of memories, PLL circuits, voltage regulators, and analog to digital converters and so on. So what you do is that first you identify all the components, I mean the building blocks of your IC. Then you design actually individually, and then you have to verify it individually to ensure all these components work as per the requirement. Then you have to connect all of them together. Okay, and then you have to do detailed verification. If everything is okay, you go for a physical design. This is where you actually going to so define the IC size, area, and also type of material and the technology you'll be using. Okay, so here it's similar like a PCB. So once you define your IC area, you have to place all the modules. Okay, the building blocks. Okay, so then you have to do again simulation to check the placement is okay, and if it's okay, you will have to connect all the components. So that's called layout here. So in the layout, again, when you have to connect all the components together, and then you have to also simulate and see whether any signals are interfering with each other. Okay, so that's very important. Okay, then once everything is fine, you'll go for a fabrication. As you know, I see I mean design, it's a very expensive process. Typically to design an IC take a lot of millions of dollars, so it's very important for you to ensure, in each stage you do extensive testing so that there will not be any problem. Because once there is any issue in an IC, you can't do anything really, because you can't solve it actually. Okay, because it's everything is inside, right? So that's the reason, you need to have extensive testing, verification, etc here. Okay, so now I'll tell you a bit on a different type of jobs in industry. So quickly, so you'll have a different type of roles. As you've seen in the product development flow, you need different type of engineer. You'll have a design engineers, you'll have a testing engineers, reliability, regulatory, quality, and so on. In production, when you come, you have manufacturing, production, quality, and so on. Okay, and you have purchase engineers and so on. Okay. So now I'll tell you about different type of jobs. So I told you in the beginning about the objective. Okay. So first is that you have to decide, right, what you want to do, and then you have to consider in different type of job you want to work. Okay. So that's very important. Both are connected to each other. So because you should have a clear idea what you want to do, in which domain and which type of job. Okay. So when you say in IC design, you have a different type of jobs. For example, in VLSI industry, you can be a design engineer, or you can be an application engineer. You might have heard like a lot of application engineers are there in Texas Instruments and all these companies. Okay, so they will visit and give a training on the products and so on. Then you'll have engineers working on the quality aspects, or you'll have engineers working in the manufacturing, or somebody will be working on testing. So different things. Huh? So when you say you choose at higher level, like okay, I want to work in a VLSI design industry. So you have different type of jobs. So now you have to choose in which type of job you want to really work. So that's very important. So so hopefully everybody will be knowing about R&D. So that's a research or design and development activities. So in many companies it's a combined role, but in companies like TA or say Xilinx or even Intel or Qualcomm, etc. So they have a separate research engineer. So their job is mainly to define certain concept, or develop certain concepts or algorithms or protocols, etc. And then they go for IP and all. The patent and so on actually. So design engineers, what they do, for example, if a research engineer develop a signal pulse noise cancellation algorithm. So design engineer may implement it either it in a DSP or an FPGA, for example. Okay, so they will practically implement it in a product. Okay, so whereas the research engineer will implement it in a MATLAB, for example, and he will simulate a lot of things. Okay, whereas a design engineer will implement it in the actual DSP or a process FPGA, then they do a lot of testing. Okay, so that's the difference. But in most of the companies, you can say over 90% of the company, it's a combined role. And this is the toughest job to get in an industry, because interview is extremely tough. The reason is that you need to have very good technical knowledge and advanced skills, and also you should have very good basic knowledge. So you should have a good knowledge on the subject that you study. For example, you want to work in hardware design, you need to know the components starting from the resistor capacitor. So you need to have good knowledge on the subjects that you're studying from first year onwards. Okay, and that's one aspect. Another thing is that getting is difficult. Another is working and surviving is even more difficult, because in R&D you have to work on different projects. Different challenges will be there. You'll have to work on say like you have to frequently switch over the technologies and other things actually. So you should be very quick in learning the things and implementing it actually. That's why it's very challenging and difficult. Okay, so you have to, and the third thing is that when you are working on different things actually, you need to have a right mentality to learn the things. You should be ready to learn, whether you are a fresher or 30 years experience, doesn't matter. So you can never be a, see, when you work in R&D, say, you can never say you are a master to anything, because you keep on learning, and the R&D is continuous learning activity. So you do certain things, the technology moves another, so you have to learn that, and then you have to implement it. There could be problems, you have to own it, you have to solve it, and so on. Okay, so the really success rate to get clear an interview for a position in R&D is just less than 20%, you can say. So so you have to understand this aspect. And if you see, like in NASCOM and all these surveys, why they are telling is that engineers are not employable. The basic reason is that most of the students don't focus on the basics. They just learn some programming, and they think that's the only thing. So that's the reason many times students are not getting. So you need to have good knowledge on the advanced skills, and same time you should have good knowledge on the basic. Okay, and you should be ready to learn. So these are the mandatory things you need to have in to work in R&D. Okay, so if you are ready for it, you should take it, because it's the toughest job in industry. Okay, you have to understand this. At the same time, this is the highest paid, and you have got a lot of opportunities. If you work in R&D, you can move to different roles once you have more experience. Okay, so you should, to work in R&D, you should be ready to learn always, and you should be ready to take challenges. Okay, And doing masters is always beneficial. Even MEM Tech is highly preferred. Even say in VLSI design or signal processing, even doing PhD is highly desirable actually, because for certain roles they want PhD itself actually. Otherwise they won't even recruit actually. So it's like that. Okay. So then you have a testing role. So their job is to do testing for products. So either it can be software testing, hardware testing, or within VLSI design, it's IC verification, for example. So they develop a lot of test protocols in various languages. I mean, for example, in hardware design, so they may have to develop, they test programs in HDL like VHDL, Verilog, etc. And also they may work on automation setup and all. I mean, by using LabVIEW and so on. So in general, you should have good knowledge on this. Okay. And one more thing you need to understand here is that, say for example, you work in any domain, say more than 2 years, okay, other than R&D, it's difficult for you to move to R&D again. Okay, so assume that you join as a test engineer, and you work more than 2 years in testing. So then nobody will hire you in R&D. Please understand this fact. Whereas R&D engineer has a flexibility to move to any other department actually. Okay, because the R&D is the core, in the design actually. So that's the main reason actually. Okay, so you have to always understand that. That's why your first job is very important, like in which domain you are going to work, because that's going to define your future. Okay. So then application engineer job is to give a training on the product. So I mean, in your college, whenever you buy any evaluation board, say DSP or FPGAs and all, there will be engineers who will be coming to your college. They will give a training on these evaluation boards, how to use, how to download the program, how to debug, etc. That's their role. They are there in every industry. In an IC domain, like all the companies like say TA and Unlock, they hire a lot of people actually as application engineers, and they will be based at various places because they have to visit the customers or the colleges and so on. Okay, because they have a lot of partnership labs in various colleges and so on. Then you have a quality and regulatory role. So as I told you, if you want to sell a product anywhere, you need to get regulatory certification. To get regulatory certifications, you need to meet certain quality standards, and also you have to pass all the regulatory tests. So that's why this is very important. These roles are there in IT companies also. So you have a different type of roles here. I will tell you. In quality, you have a three roles. Say one is a design quality engineer, another is product quality engineer, and third is supply quality engineer. So the job of design quality engineer is to ensure the R&D and the testing team, they follow proper, quality guidelines while they design a product and while they perform the testing. Because as per this regulatory standard and other things, you need to always have a testing evidence, or the design evidence and calculation. So they will ensure they follow all these guidelines based on certain standards like ISO 9001 or various other standards. Okay, so they will ensure there is a proper documentation. They follow, all the guidelines and so on actually. So it's a mostly not much a technical role. Okay. So then you have product quality engineer. Their job is to ensure whatever product is manufactured in the factory, it's meeting the quality guidelines. Okay, and it is tested thoroughly actually. So that's their job. They do incoming quality check. They will monitor say the production, how it happens, and also they will do the verification of the final test results, etc. Okay, so that's their job. Then you have a supply quality engineer. So this is an important role. As you know, any product has made a, has made up of different components that is coming from different suppliers. Okay, so it's the responsibility of the product company to ensure their product meet the quality guidelines. So you have to ensure whatever parts are used in your product meet all the quality guidelines. And if the part fails, for example, you need to really find out why it fails actually. So the supply quality engineer is an interface between the product company and the supplier actually. So suppose if something fails in the factory or field, they will report the issue to say the the supplier. For example, and, your processor fails, for example. So then you may inform to Texas Instruments, for example, and then they will analyze actually why it failed. So they will ask you a lot of questions. They will ask you maybe to even to share your design and other things, because they need to really identify why it failed actually. Okay, so once they identify it, then you will have to correct it actually, because you have to improve the design there, because finally your goal is to reduce the failure. So you have to improve. So then again, they will work with the R&D team and all. So once they improve it, then again you have to do extensive testing to ensure whatever improvement they have done is fine actually. Okay, so that's their role. So they're acting as an interface between the suppliers and the product company. Okay, so there are a lot of opportunities for them as well. Okay, then you have a regulatory role. So there's you have two roles there. One is a regulatory engineer and test engineer. Test engineer job is to perform regulatory tests like EMIMC test, safety test, and other things. Okay, so even freshers are hired like companies like ULTV and all that. I mean, there are many in India. Okay, So then you have a regulatory engineer. So when you design a product, you have to follow certain regulatory guidelines for for every country. Assume you are designing a product for US market, so you need to have low radiated emission, conductor emission levels, and you need to meet certain criteria. So what typically regulatory engineer will do is that once the product is when the product design start actually, so they will involve there, and they will work with say R&D engineers. They will make them aware, okay, the requirement for the particular country. So accordingly R&D engineers will design the product. For example, you want to design a product for US, you need to have a lowest emission level. So to achieve this, you may have to have a good grounding, or also you need to have a, I mean, maybe additional shielding, and also uh, you know good enclosures and other things actually. Okay, so that's very important, and sometimes you may have to even add additional filters and all. So they will work with R&D engineers to ensure that these things are taken care in the design itself. Okay, because otherwise what happens is that once you have regulatory test fail, again you have to repeat it, and performing the regulatory test is very expensive actually. You have to understand this actually. Okay, so they will work with them, and to ensure your product meet the regulatory requirements. So they are there in IT companies. For example, Wipro has got EMC lab in Bangalore, and HC labs in Chennai, for example. Okay, so even they do have these roles. So some of you might be working on that as well. Okay, so then you have a manufacturing roles. So you have a manufacturing engineer, production engineer, and test engineer. So the responsibility of a manufacturing engineer is to ensure the factory has the right setup and you know tools actually for manufacturing a product. Assume you're manufacturing car audio systems. Okay, compared to say 10 years back, now in car audio system you have a lot of Wi-Fi modules and other things, right, or Bluetooth modules, right? So when you are manufacturing, you need to really test the signal strength and all, actually both the transmitter, receive power, etc. So you need a spectrum analyzer, for example. Okay, so they will ensure whatever tools required in the to manufacture these products are available in the factory. Then your production engineer, their responsibility is to ensure the products are manufactured as per the requirement. They will manage the technicians who are assembling the products. Okay, and then they will also ensure daily or weekly targets and met actually. Okay, so then you have a test engineer. They do extensive testing of the product, and once the product is tested, it will be shipped out actually. Okay, after quality verification. Then supply chain engineer's job is to purchase the component, negotiate with them on the pricing and other things. So doing MBA is helpful here. And the service job is to service a product. Okay, and so you need to also consider various aspects, like you may have to travel a lot locally and internationally, so that all depends. So then sales and the marketing role is engineers responsibility is to sell and market the product. So they are also basically electronics products. Okay, so in automotive they are typically mechanical engineers. Okay, because they should have good overall idea of technical, and also they should have good understanding on the technology. So that's why it's they're typically engineers. Okay, so MBA is again preferred. So to conclude, I would like to say, like, you have a clear objective, then you understand in which domain you want to work. To work in R&D, you should be really prepared. You should have very good technical knowledge. You should be ready to learn always, and you should have the courage to take the challenge. So that's very important. Okay, I mean, you'll have to work in a very pressurized environment, and so you need to know these things. Okay, so you can choose your field, and R&D is not the only job. You have a lot of other opportunities as well. Okay, so this is about different type of job. Now I'll tell you about the expectations and this required skills for industry. So I'll start with the resume. Okay, so the first and foremost thing for you is to have a very good resume with the right skill set that is needed by the industry. Your resume is screened automatically in industry. Okay, so you need to have a right skill set in your resume that is needed by the industry, because it is screened automatically. So if you don't have the right skill set, your resume is rejected. Then you don't have any chance for interview. It's equally applicable for a campus interview. Okay, that is one aspect of a resume. Second is that assume you already joined, got an offer. Okay, so once you join your company, the first thing the company will ask you is to submit your resume, because they need to see your skill set to decide where to put, in which project to put, in which domain to put. Okay, so it's important for you to have a right skill set in your resume in that time. Okay, so that is the reason I'm telling you, if you have an offer, you need to study even more actually, because you need to, if you want to, especially if you're an IT company. Okay, because you need to have a really good skill set to get a job in core domain. Okay, so once you get your resume is shortlisted, then you will have an interview. Okay, so you have a different type of interviews. Say like one is technical interview, next is HR interview. So the purpose of technical interview is to assess your technical knowledge. Okay, so then you have I mean a technical interview can be minimum 2 rounds and it can go beyond 5 rounds. Okay, I mean say in VLSI domain and signal posing, etc. And the HR interview, the purpose here is to identify behavioral skills, like say to assess your communication and presentation skills in English, and also to see how good you are as a team player, how good you are in ownership, and how flexible you are, because these are the three characteristics that any person need to have to work in an industry. Okay, so because in industry you have to work as a team and you need to own the things and so on. Okay, so HR will assess. Both interviews are really tough. I mean, to clear a technical interview in core domain, it's very difficult. Only 20% of the people typically clear that. Actually, it's difficult. You really need to prepare. Okay, so in the first round of interview, what we typically do is that we'll ask a lot of questions on your project, because that's the most important thing for you. So we'll ask a lot of questions on your project. Say like we'll ask you to draw the block diagram, ask you to explain the things. Okay, and assume you use certain evaluation boards. Okay, so we will ask a lot of questions on that evaluation board. We may ask you to draw the block diagram of the evaluation board. Why you have used certain things and so on. Actually, okay, and because you should able to explain that. Actually, assume you use a Arduino board, you should able to explain to the interviewer why you have selected, because you should have proper reason. You can't say like it was there in the college and or it's cheaper. Actually, that's not the reason. You should answer it technically. Okay, for example, that's what we expect in the interview. So then we'll ask the questions on the skill set and the projects that you have done, or all the training that you have done. Actually, whatever you have written in the resume. Okay, so it's important for you to study the resume thoroughly. Actually, when you're going for interview, because we'll be asking a lot of questions on that. Once you clear that, the next level is will start, and the next level will ask you the questions on the basic, whether for software engineer role or hardware engineer role. We'll ask a lot of questions on the electronics. We'll ask you to do the block diagram for the components, or maybe the properties of the components, and ask you to explain, and maybe to do some calculations, maybe to derive certain formulas, and so on. Actually, so you need to really study the subjects from the first year. That's why I'm told you the success rate is just 20%, in a technical interview. So if you need to clear, you need to study. There is no shortcut there. Okay, so these are the things. Actually, so I mean, again, depending on industry. So typically in VLSI design, and what happens is that, and that's the toughest job to get. I mean, one person will ask you only on semiconductor physics, somebody will ask you on analog design, somebody will be asking you on op amp, and something like that. One person will interview 1 hour in that only particular domain. Actually, so they will really go in very depth, deep. Actually, so you need to really study that. Actually, so one is good knowledge, good technical skill set you need to have to screen get your resume shortlisted. That's the number one step. Then do second is to have a very good basic knowledge. Then only you will be able to clear technical round. Okay, once you clear technical round, we will go to HR round. In HR round, they will have typically GD, group discussion, and they may also do psychometric tests, or they will ask a lot of tricky questions to you to assess you on your communication and presentation skills, and also team player, and also ownership and flexibility, because these are very important to work in an industry, because you have to work with different people in different countries or different teams and so on. Okay, I mean, so you should have a good communication, and you should be ready to work as a team. Okay, because there is no individual sort of working in an industry. It's always team. Okay, and then you should take ownership in completing your task. And the last thing is a very important flexibility, because you should be ready to do different type of work in an industry. So you should be very wise and careful when you answer this question in an interview, because they may ask you, the HR will really want to know actually your goal and other things. So he'll ask you, suppose your interest is to work only in doing design, he will ask you if you if we want you to give a testing job, or something for a say certain period of time, will you be ready to do? So your answer should be always yes, because as you know, in product development flow you have a different task. So sometime if there may not be engineers working in testing at that point in time, so you should be ready to do that activity. So that's how what industry expects. Okay, so you should answer wisely, otherwise you will be straightly rejected there itself. Okay, because HR interview is also not so easy. Okay, so that's one aspect. Another thing is that but you should never ask a salary in interview, because that's because for freshers the salary is already defined in each company. Okay, so you should never ask the salary. You could say as per company expectation. That's the best answer you should give. Okay, I mean, the third thing is that once your interview is done in both technical or in HR round, they will ask you a question like, do you have anything to ask to me or to us? Okay, so you should ask something on the company, the technology they work, and the product they work. Okay, so what this means is that you should study about the company, what work they do, what technology they use, and so on. Okay, you should ask questions on that. That's what they expect. Actually, suppose if you don't ask anything, that's not a good indication. So I mean, you also right to know what you want, what you will be working, and so on. So that's very important. Okay, And so this is how, I mean, a candidate is selected. You clear technical, then you go to HR, and if you clear HR, you get an offer. Okay. So these are the important things. So for resume is most important thing, first to get a interview call or to get a right project if you are already placed. So it's very important, you need to focus on resume. So now I'll tell you about the skill set that you need to have it in your resume. Mandatory, anywhere in any type of industry you are trying, these are the mandatory skill set you need to have in your resume. So I'll tell you a bit on embedded system before I start. Embedded system, it's a combination of hardware and software. So when you say hardware, so embedded system is made up of DSP, microprocessor, controllers, or an FPGA. So if you want to work in an embedded system, either as a hardware engineer or software engineer, you should know the architecture of DSP, microprocessor, and FPGA. This is a mandatory skills actually. Otherwise, you won't be getting an interview call. Or I mean, even if you are already hired, actually, they may not be putting in a core domain. Please understand this thing. Every industry work on all those things, so it's a must skill you need to have. And also you need to do some mini projects on this. Okay, I mean, you can do a final peer project maybe in a processor, and mini projects in DSP and FPGA, so it's a mandatory thing. Okay. And second thing is that you need to have a good knowledge in electronics component. Okay, so knowing programming is not going to get a job in embedded system. Please understand the thing. If you don't know electronics basics, you will not even clear the interview. Okay, so it's as simple as that. Because as I told you before, when your system operate in different conditions, so you need to do, I mean, a lot of corrections in the software. You need to develop the algorithm based on the properties of the devices. So you need to have good fundamental knowledge, otherwise you won't be able to develop the algorithm. Okay, so it is something which you have to write. Okay, so you need to know the behavior actually, how the offset varies, and how you'll able to correct and other things. So you should know this actually. Third thing is that without by knowing in DSP, you won't get a job in embedded system, because without DSP you can't do anything in an embedded system. Because DSP means, here you in any system you do a lot of filtering. So you do FAR, IAR, or different type of filters. And also in every embedded system you have a lot of data transfer. It can be say data transfer within the system itself, or to external, like maybe to ethernet, or USB, or it could be a wireless communication. Okay, so when you are having this type of communications, you need to do encryption, you need to do compression techniques, etc. That's again signal processing actually. So that's why you need to have this skill set. But language, it's not so critical. Okay, please understand this fact. You need to, if you know one or two language, that's more than enough. You need to know either C or C++, and MATLAB is mandatory in industry. Okay, so HDL is mandatory, and RTOS mandatory, and one DSP, processor, and FPGA is a must. And you need to know all the communication protocols, because you will be communicating with a different type of devices. Okay, so you need to able to develop the software for that. And you should have good knowledge on the device drivers and kernels, etc. And so a lot of positions here in embedded software, and driver, and a lot of opportunities there. Okay. These are the skill set for a signal and image processing engineer. So you need to have good knowledge on DSP, image processing fundamentals, mathematics. That's a basic thing. Second thing is that you should have good knowledge on the architecture of DSP, processor, and FPGA. Okay, because FPGAs and high-end ARM processors are also used for signal processing and image processing. So you need to know that, because you may be implementing in one of these things when you join a company. So you should have good knowledge on programming language like C or C++. MATLAB is mandatory, and you need to have good knowledge on HDL. Okay, and also you should have good knowledge on RTOS. Okay, and you should also know the communication protocols, because you have to communicate with a lot of devices actually. Maybe you'll be getting data from another device through I2C or SPA, or you may be getting the data from a PC, for example, through Ethernet, something like that. Okay, so you should have a good knowledge on this as well. So a lot of positions there. So I mean, a lot of companies work on this as well. So you can be a DSP, image processing engineer, testing and quality, and image quality, and so on. Okay, a lot of automotive companies also work. Say if you take Harman work, I mean, in Bangalore, or Continental, or Bosch, even in Coimbatore and Bangalore, for example. Okay, so AI and machine learning is a technology. Okay, so again, I mean, to work in this domain, you need to have a few things, and a few things you need to know. One is you need to have good knowledge in machine learning and AI fundamentals. The second thing is that you should have good knowledge in DSP and image processing, because the reason is that most of the time it's in any system, it's used in combination. Okay, so and you have to understand one more thing. This AI and machine learning, it's a technology. It's used in every embedded system, and it's also part of signal and image processing and development. Okay, so you need to know this actually. Okay, and but you will be implementing either in a DSP or processor, or an FPGA, or even a PC actually. So in a system, it will be in any of the three actually. Say DSP, processor, FPGA. So you should know the architecture. You should have good knowledge in programming like C++ or Python, and MATLAB is also required. HDL is again required, and you should have good knowledge on the distributed computing OS and the mathematics and so on actually. Okay. So for hardware engineer, you need to have good knowledge on schematic tools like CAD and schematic graphics. Also, you should have good knowledge in the PCB design fundamentals. You should have good knowledge in simulation like PSpice, and also you should have good knowledge in HDL and all, because you may have to develop the test script for bringing the board up actually. Like you have to do a basic test on the board, so you have to develop some small code. So you should know it. Need to know the architecture of DSP, processor, and FPGA and memories. Should have good idea on the communication protocols, because for each communication protocols you have to consider a lot of things while you design a product. Okay. uh, so the last thing is most important actually. I mean, you should have a very good knowledge on the components, starting from your resistor, capacitor, to op amps, to analog to digital converters, I mean electromagnetic compatibility and so on. Okay. Opportunity wise, hardware engineers got the most varieties of opportunity, and this is a really good field actually. At the same time, it's really difficult to clear, clear the interview, because there will be a lot of questions and all actually on the components and so on actually. You can work in the multiple roles actually. Okay. So I mean, design engineers in the various domains in electronics or in FPGA, PCB design, signal integrity, or no, the wire harness. This is about cable design and electromagnetic compatibility, a lot of things. Okay, so a lot of companies in India. So in VLSI design, it's a very vast field, and this is the toughest field to get as well. So the basic thing you need to have is that you need to have good knowledge in digital design, analog design, the RTL design. You should have good knowledge in semiconductor physics. You should have good understanding on the processor as well. Okay, because in many time you will use certain processors also in the ASIC and all. Then you should have good knowledge in HDL, and also you should have good knowledge in the programming language, because you will be doing a lot of scripting for verification, etc. You have to understand one thing: as a fresher, you are not sure in which part of IC development you will be in actually. So you should have all those skills. Okay, so you should have some domain knowledge also. If you are developing an ASIC, for example, in audio application, so you should have good knowledge in DSP, for example, or for a wireless chip you are designing. So you should have good knowledge in that, for example. Okay, so a lot of position like design engineers, layout, verification. Then this is a tool developer, and then physical design, reliability engineer, etc. Okay, so a lot of companies, almost all IC manufacturers are having R&D centers in India, at least over 90%. Most of them are in Bangalore. Okay. So these are the skill set that you need to have in your resume. Okay, and when you say high level, you have a three different type of jobs in industry. One is hardware engineer, another is software engineer, and the third is a VLSI design engineer. So when you say software engineers, the software engineer can be embedded software engineer or signal processing engineer, or engineer will be working on machine learning algorithms. Okay, and IoT is a mix of say like multidisciplinary domain. It's a mix of technology we use there, and it's an application of embedded system. Okay, it's not a separate domain, please understand this. Okay, so now I'll be telling you on the components and tools used in industry. So it's very important for you to know these things, because you need to have them in your resume. So this is exactly from the skill set it's coming here. Okay, so you need to know what are the components used in industry and the tools. Okay, so that's very important for you, because if you want to work in core domain. So as you know, I mean, ARM processor is the most popular in industry. So you have got a plenty of ARM processors. So you can see the process, especially for machine learning or neural network or cloud, and network security, I mean physical security and so on actually. So that's what again I'm repeatedly telling you, without knowing the architecture of processor, you can't develop a machine learning algorithm or any algorithm. Okay, so it's important for you to know this. Okay, so then you have other process from other companies like NXP. They do have ARM processors and different process. You have TA, microchip, and ST. Okay, so ARM is most popular. Over 60% of the industry uses. In automotive domain, you have a lot of other like Renesas and Fujitsu. So those are different unique architectures. But if you know ARM, that's good enough actually, because then you can learn other easily. Okay, so you need to know DSP if you want to work in core domain. So you have a DSP from TA and analog devices. TA has a 6000 series DSPs. This is a high performance DSP mainly for communication and image processing applications. You have two variants here. One is pure DSP when multi-core, and also you have a DSP plus ARM. I know it's also multi-core actually. Then you have a low-end DSPs 55 series. It's used in audio applications and industrial applications. Okay, and then you have analog devices DSP. So when the various types are there, like ADSP to Blackfin to Shark and all. Blackfin is mainly used in automotive in industry. So it's used in to implement software defined radio or in audio applications, navigations, ADAS and all. Okay, so you work on one of these DSP. Anyone is more than enough. So FPGA is again part of embedded system. So you need to know FPGA. So you have only major two vendors, Xilinx and TA. At least 90% of the industry uses that. Similarly, DSP, TA and Unlock, the 90% of the industry uses it actually. So then you have unique DSPs actually. I mean, so you need to always focus something that's commonly used in industry. Okay, so you have a high-end 7 series FPGAs, and also you have a system on chip. It's a combination of FPGA plus ARM processors. Even it has GPU also in different variant actually. Okay, so you can work one of them. This is an example of a computer accelerated platform from Xilinx. It's used in supercomputers and base stations. It has a processor, programmable engine, and also I mean A and DSP engines. It can even communicate over 100 and 12 Gbps actually. It's extremely powerful actually. Okay. And so then you have Ultra FPGAs. So I mean later Intel acquired it, so now it's called Intel FPGAs. So they have a different varieties of FPGAs and system on chip. It's a combination of ARM and FPGA. So you can work one of them. I'm sure that you'll be studying about FPGAs in a college, and hopefully you'll have a evaluation board as well. Okay, so now I'll tell you a bit on IoT. So this is a block of I mean in IoT you have a node and router and cloud. Okay, so all are based on processors. Okay, so if you take a node, you have a sensor, then you have a signal chain. So this is called the signal conditioning circuit, where you do an amplification and you do some sort of filtering. Okay, and then you will have a power management circuit, like a battery circuits and other things. Okay, so then you will have a processor, and I'll have a certain Wi-Fi modules, etc. Right, to transfer the data. So to work in this domain, you need to know multiple things. One is that when you get the data from the sensor, okay, so in the signal chain circuit, you amplify it and you do a filtering, and sometime you will have an analog to digital converter here already. So you may convert into digital, or some cases you will use the ADC in the processor itself. Okay, so whenever we get any signal, you have to do a filtering actually in the processor also. Okay, so the hardware filter is not sufficient enough, so sometimes you may have to do dynamic filtering and also different type of filtering, etc., like FAR, IAR and other things, so depending on application and type of signal. Okay, so to do that you need to have good knowledge in DSP. Okay, so then once you implement the algorithm in a processor, you have to always also consider a few things actually. So you have to optimize the algorithm in such a way that it will consume less memory and less power, etc. So that's very important. So to do that you need to know the processor architecture. Then you need to transfer your data through Wi-Fi module. So to transfer the data, you need to know the communication protocols. And when you do a data transfer, you always do compression and you do encryption actually. So you need to know that as well. Okay. So in conclusion, to work in IoT domain, it's a multidisciplinary domain. You need to have good knowledge in electronics. You need to have good knowledge in signal processing. You need to have good knowledge in communication module. I mean the protocols, and also you should have good knowledge in the processor architecture. Without that, you won't able to work, and even you won't get a job actually, because you won't even able to clear the interview. Okay, so please understand this. It's not a separate domain. It's an application of embedded system, and it's a combination of multiple things. Okay, please understand this thing. If you know all the communication protocol, you are not going to get job in a IoT domain. The reason is that you may have to work on various things actually. Because sometimes your job is to develop the software in the processor to optimize the power consumption, or to acquire the data from the sensors. Okay, so that may be your job. It's not always I mean say communication protocol. So you need a multiple skills here. So when you come to cloud, you have a very high end processors. Okay, so I mean I'll tell you on that. So you typically use different protocols like Zigbee or Bluetooth or Wi-Fi and all. Okay, and this is an example of a cloud server from HP. It's a real product. Okay, it's made from I mean Texas Instrument DSP. Yeah? So it's a very high-end multi-core DSP plus ARM processor. So okay, so again I'm telling you. So I mean cloud, servers actually it's designed based on a processor or maybe a DSP or a very high-end FPGAs or a combination of these. Okay, so to work even on cloud, you need to know the hardware. Without knowing the hardware, you cannot develop a software and you cannot implement it efficiently, because in a sense, software development is not just about writing the program. It's about how to implement it efficiently actually, because how to execute a program, I mean, an algorithm fast, and how to reduce the memory usage and all of the things. So you need to really know the hardware architecture. Without that, you can't develop a software. Okay. This is an example of machine learning implemented in a processor. This slide is from Xilinx, sorry, Texas Instruments. So here it is used for object detection and classification. So this here they've shown how to implement it in an ARM processor. Okay. So this is a comparison of the performance of FPGAs for machine learning applications. I've taken it from Xilinx. So and you can see like it's also, I mean, machine learning algorithms are also implemented in FPGA. So it's very important for you to know all these platforms, because you don't know in which type of component you'll be using in your project. So that's the reason you need to know DSP, FPGA, and processor. This is a mandatory and the basic skill set, and the knowledge that you need to have if you want to work in core domain. Okay. So now I'll tell you about the schematic capture and simulation and layout tools. Okay, so you have a major companies, but in this like Cadence and Mende Graphics. So at least 70% of the industry uses it, and then you have other tools say like Altium and Cats, Sukan and other things actually. So that is also used, but it's not as popular as these. Okay, and it's required for hardware for students who want to work in hardware domain. It's not required if you want to work in software domain. Okay, so you can get this evaluation board versions from net like OrCAD or Allegro. You can learn any one of that. That's more than enough. And PSpice is mandatory for you to learn. You should know how to simulate it and all actually. And then these are the tools used for signal integrated. I told you, right? So once you do the placement, you need to simulate it and see how the interference and other things. And also you have, after routing, you have to see when how is the interference of the signals and also the signal quality, etc. So these tools will help you to do that. You can download it, the evaluation version, and you can practice it. Similarly, Mende Graphics is there. So hyperlinks is very popular. I mean, it's used for signal entity check. It's also used for thermal simulation and so on actually, and also to measure the electromagnetic radiation and all. Actually, you can simulate those aspects. Okay. So FPGA design, you have Xilinx and ISC Vivado and ISC, and this is for the current generation, say 7 series or 6 series of FPGAs onwards. This is for previous generations, say like five, third series and other things. Okay, so then you have Intel Cortex for Intel FPGAs, and your model sim mainly for simulation. For IC design, you have both when Synopsys and Cadence used actually in front end and back end, etc. So as I told in the beginning, MATLAB is a mandatory skill set in software engineering you need to have. Either you work in embedded software or DSP or machine learning. It's mandatory. It's not for signal processing alone. It's used in industry because it's used whenever you do a simulation or you develop a concept actually. Because you implement the concept in MATLAB and you do simulation and you prove it, your concept is fine, and then only you're going to implement it in actual processor or the platform. Okay, so it's very important for you to know this actually. So you need to learn if you want to work in software. So it's used everywhere in AI to DSP to power electronics to control system. You name anything, it's there actually. And it's also used for embedded system and FPGA development also. So they have a good add-on tools and all actually. So it's important. So Simulink is also very important because you do a lot of model-based design and simulation actually. I mean product development. So it's good to learn that. Okay, so if you're interested to work in testing domain, you need to learn LabVIEW because that's very important, because you have to develop the automation setup and other things actually in LabVIEW, and it's also used for FPGA development. Okay, so now with this I've told you about the skill set that you need to have in your resume, and also the major tools and components used in industry, in any type of industry anywhere. Okay, so the most important thing to enhance your career is to have very good projects. Implemented in processor, DSP, and FPGA. Because as I told you, getting a job, now the first step is to have a good resume. Okay, to have a good resume, you need to have a good skill set in the resume. Okay, so you need to work on all of the things. There is no shortcut here. I mean, you have to do projects. You need to have a good knowledge on the architecture. Doing MEM Tech is highly good, helpful if you're going in want to work in R&D. You can do some courses. Okay, so you may not be studying everything in engineering, so you can do some courses. I'll tell you on that. You can do project in industry, will help you. I'll tell you a bit on internship also. Paper publication is also very important because you're publishing in journals like IEEE or Billy Eastern or or Science Direct. All of the things so will help you really. Okay, then networking with seniors and industry people are also very good because you'll get to know really what an experience from industry and so on, and that's why I'm here today. Okay, so I mean, see, you're studying a lot of subjects in engineering. Okay, so I mean, once you do internship, you will understand actually why how these subjects are useful in industry. Okay, so I told you about the reliability test, right? So you hope you also have got some idea, like why the selection of component is a major criteria, right? Because if you have a selected component with higher tolerance, what are the impacts, right? So when you do an internship in a company, you will get to know all those things. You work on some practical problems or design, so you will really understand actually what are the problems you face and all actually. So that's one aspect. Another aspect is that you will get a chance to work on the tools used in industry because that will help you. And the third thing is that when you do an internship, you work with the different people. Okay, so that will help you to improve your communication and presentation skills, because that's very important for you to get a job. Okay, so because it's very very important. And the fourth thing is that when you do an internship, you will work with the different people, and they could help you to choose yeah, I mean help you to choose your domain or a field, or they could mentor you really, you know and they could groom you actually in your okay, so they could be a mentor to you actually, so that way really it will help you. So that's these are the advantages of internship. So you could do internship after say third semester onwards, and you can try it in various company. NILT and Calicut also have paid internship and all in embedded and all. Okay, so or you can find a lot of companies in various places in India. Okay, so now I'll quickly tell you about different courses in core domain, so which you can do. These are training center based courses, and later I'll tell you about online learning. Okay, so in embedded system, they'll teach you on embedded C and other things. So in Kerala, if you see like you have NLT in Calicut, they have got very good course. It's nice syllabus. Okay, and I think in even here in DC in Trivandrum also has got. CDAC also offers, so you can Google it. You will get a lot of information. Okay, so IoT, you have courses actually in CDAC, and I think even NLT also has this there's such course actually. They will teach you on IoT protocols, processor, and other things. Okay, so VLSI domain is a very vast field, so you need to really decide what you want to do in this. Okay, because even in NLT or in CDAC, the courses the focus is typically on the front end actually. Okay, if your interest is to do a back end design or layout, then you need to go to Bangalore. In Bangalore, a lot of institutes are there. You can join some courses that will really help you to get a job. Okay, so DSP and image processing, they'll teach you on DSP fundamentals. So the Bangalore is the best place to go. If you see Cranes University has got paid internship actually. So if some of you are interested in that, you can work on that. So as I told in the beginning, typically DSP or image processing engineers is paid almost twice as an embedded software engineer, and the VLSI engineers are paid at say like roughly 3 to 5 times of an embedded software engineer. So once the complexity of work increases, and once you need a lot of skills, you are paid more, huh? So it's at the end of the day it's like this. It's knowledge is proportional to your salary, yeah? It's like that. You have got good knowledge and good skill set, you'll get higher salary. That's the basic. Okay, and AI and machine learning, typically they'll teach you on AI and ML fundamentals, but this is not sufficient ideally, because if you really want to work in an embedded domain, okay, so you need to have good knowledge in the processor and other things. So you need to have a good knowledge on that as well. So you could do these courses, say CDAC or different institutes you can find in various places. Okay, and then you need to have some mini projects done on the hardware platform like DSP or processor and FPGA. That's very important. Okay, so electronics product design is a good course for hardware design. The NILT is very famous in Calicut, is very famous for that course. It's a nice course. They'll teach you on electronics hardware design fundamentals, the packaging and so on actually. So you could join there. Even they do have placement. So electromagnetic compatibility, it's a very few days course. They will teach you on electromagnetic compatibility, and also, what are the guidelines you need to follow, to design a product to meet the requirement. So Samir in Chennai offers a 3 days program, at least once or twice in a, year. So you could find it from their website. So now I'll tell you a bit on online courses. So you need to understand few things. So difference between online and training center courses, that in the training center courses, you will have a hardware platform and also a lot of software development tools. So you will get a chance to work on real projects, and also you get a chance to work on all these platforms. Whereas when you do an online course, you will not have the hardware with you. Okay, and you should not do any online courses just for certification purpose, because certification is not having any value in industry. Okay, so you will have a value only when you do some projects. So if you do any online courses, please ensure you do some project in a hardware platform. Okay, so you can use your evaluation boards in your college for implementing these things actually. So that is very important. Okay, and if you want to work, for example, in embedded software, it's a mandatory for you to do some courses in machine learning, AI and IoT. Okay, so you may not be studying this in engineering, so you need to do some courses here, you need to do some projects, then only you will get able to clear an interview. Please understand this. Just by doing an online courses, you will not able to answer the questions. We'll ask you a lot of questions on the fundamentals, and then we'll ask you how you're going to implement actually, because we are interested to see what you have done by learning this actually. So that's very important. This MIT Open is, it's a free course site actually, and you can also find a lot of YouTube videos, and also you can find a lot of when it's a webinars or online course. It's not online courses, I would say. Recorded videos, or tutorial videos and other things. You can learn from that as well. TA or Xilinx or NXP or Intel, a lot of them you can register and you will get a lot of information there. So when, if you're interested, you can also buy some of the validation boards either for your project or for learning. You can work on say like a Raspberry Pi board. It's a good ARM processor based board with a lot of interface. Or you could work on TA if it's the C55 series or 67 series DSPs, or maybe Blackfin DSPs and so on actually. Or you can even work on FPGA validation boards actually. I mean, or you can also get it from Intel also. So I just considered Xilinx. These are all of just example. You could find a lot of them in net if you search. So these are the subjects you need to focus really if you want to get a job in a core company, because as I told you, the success rate is just 20%. Okay, so you need to really focus on the basic, and there is no shortcut actually to get job in core domain. Okay, so you need to really focus on the subject that you study from first year onwards, from the logic gates to the resistor capacitor, all of them. Because the questions could be like this, in interview to a software engineer will ask, actually will ask you, okay, you've been a draw a circuit, and then you tell actually these are the tolerance of the parts. Okay, so you will ask you actually how much will be the error and how you're going to correct. We'll ask such questions to students. Okay, so you need to show, calculate and show them this is the error and this is how you're going to correct it actually. So you need to know really the properties of the components and the behavior actually in different conditions. Okay, so it's very important. Okay, and the same way hardware you need, or VLSI you need to have good knowledge on a lot of electronic subjects, and also you should have good knowledge on you know I mean in electromagnetics and radiation and microwave and digital communication and so on. So it's very important actually. Okay, uh, so so what are the next steps mainly? So what you need to always have is that you need to have a very good resume, with the skill set that I have told you actually. Okay, please ensure understand one thing in industry. If in core domain you have only three type of jobs, it's software, hardware, and VLSI design. When you say software, it's either embedded software or signal processing. So to work in this domain, you need to have a knowledge in DSP, FPGA, and processor. This is a mandatory requirement. Okay, so you need to have them in your resume. Okay, because then only you're going to get an interview call, and also you'll get able to get a job in core domain. Okay, please have all the details in your resume, like your project skill set, the training details, or the paper published and courses you attended, etc. Okay, and also you need to have a very good covering letter. Okay, so where you have to, also you need to have a good objective in your resume and covering letter. Okay, and also you should have a brief overview about your experience and knowledge in your covering letter. Please don't send resume with, like, with a covering letter, like, please find my resume for this position. Okay, don't do that. You have to have a clear objective there, and you have to highlight the person who get the resume, and should have an idea actually about you. So that's very important. Okay, and please ensure there is no grammatical and spelling mistake in the resume. So next thing is that you need to have a very good LinkedIn profile, because most of the hiring happens through LinkedIn. Okay, and not for freshers as such, actually in general. Okay, and also uh, you know you can connect with the various follow various companies and connect with HR managers. Okay, but the reason is that that will help you, to connect with a lot of startups and other things. So that will help you to get internship, or maybe to get a chance in doing projects there, or even to get a job. Okay, because there are a lot of startup as well actually. So that's how you have to connect. You connect through net, and then you can get a lot of the things actually. Okay, so you need to make your profile like a resume. You need to have all the, just don't write your say name, or just the college and qualification. That's not adding any value. You need to really have your skill set. Okay, so then only you'll get some benefit out of it. And then you can also register in job sites. Okay, so then continuous learning is the key. So you need to always learn. If you want to work in R&D, you can't stop learning. Okay, so it's like that. And you can also do ME Tech if you want to work in R&D. And one more thing you need to understand, there are over 2000 companies in India working in core domain. Okay, from small companies to startups to all multinationals. So now 99% of the companies will not put a job requirement for freshers or people with less than 2 years experience in industry. Okay, so please find the companies, search in Google, find the companies in your field of interest, and you can learn the skill set that needed for in that particular domain, and then you can keep on applying. Actually, you can upload your resume, or you can send your resume. Okay, you'll definitely get interview call. Okay, and then it's your knowledge, and also the knowledge in the basic that will help you to get a job. Okay, so this now I'll quickly go through the organization structure. So now when a product company will have business leader, he will manage the organization completely, or the site, for example, under him there will be R&D head and quality head. Actually they will be managing different their departments actually. So he will overlook all of the activities. Okay, so in R&D we'll have a project manager, engineering manager, and quality manager. The job of a project manager is to manage the projects. Engineering manager will be responsible for the product development, so all the engineers will report to him. And the quality manager will manage the quality and regulatory team, and they will ensure all the quality and regulatory requirements are taken care in the design. Okay, and these are the different positions, the green highlighted ones are for the freshers. Suppose if you get a job in an industry, any IT company, anywhere, so as I told in the beginning, they will see your resume and they will decide actually in which domain to put. Okay, so they could put you in a quality testing and anywhere actually, depending on your skill set. Getting in R&D is the toughest part, as I told you. So you need to have really good skill set. Okay, so I mean, this is typically the growth path. You can grow in pure architect technical role. Okay, I mean, so these roles are equivalent to a director or vice president, or you can grow in managerial role, or I mean anything. Okay, so if you want to go in managerial role, once you become a project lead, that's typically after 5 years of your experience. I mean, you could do an executive MBA. I mean, if you're interested, but not mandatory. Okay, and most of the companies also sponsor it, and then you can move to managerial ladder. Okay, so this is a bit on the technical path. I mean, it's all pure technical roles. I mean, you need to have really good technical knowledge and mostly master's degree. Okay, really to reach there. And it's all really challenging roles. Okay, so in manufacturing also you have a lot of positions like purchase and production, etc. Then in quality also you have like a design quality, product quality, and all. So these are the lots of freshers. And I was telling you about this marking, right? So CE and all this for European Union, and UL is for US and so on actually, and so for different countries. Okay, so you need to meet all the regulatory requirements. So a lot of positions. Okay, so with this I've completed my session. So you feel free to yeah, I think a lot of questions are there, so I will answer each of them. Okay, so maybe we can have another 30 minutes if you're fine, because I'm okay with that. Okay. Okay, see, the application engineer job, it's to give a training actually on how to use the product. Okay, I mean, so for example, application engineer can be, for a product or can be for a software. Assume, you're getting a MATLAB, or you're getting a tool from Cadence, for example. They will come to your college, they'll conduct a training. So one of their job is to give a training, and also, one is just about explain the product, and one is to really work with you to help you to implement something actually. So that's the responsibility of application engineer. They need to have a good technical knowledge, and also they should have good knowledge on the tools actually. So that's very important. Okay, for example, you're working on certain FPGAs, and also sometimes you will face technical issues. So you could reach out to the application engineers, and the issue is critical and you're a big customer, definitely they'll come to your office, they will work with you and to solving these issues. So that's the responsibility of them. Okay. No, you can do internship, in any company actually. It doesn't matter. Uh, so first I will answer the questions, that is posted here, and after that I can, you can unmute and you can ask me directly. Okay. See, I mean, there are a lot of electronics companies in Kerala, in Cochin, or in Trivandrum, or even any places in India, for example. So you can do anywhere. You can do it in the manufacturing companies also, because as I told you, in product development flow, you have different phases. So it's important for a design engineer to know how a product is manufactured and what are the things considered in manufacturing. Okay, because that's very important for him to consider while he design a product. Okay, so you can do it anywhere actually. No, it is important actually. See, it will help, but it is not the only factor that is considered in a resume. Okay, please understand one thing. If you have a good skill set, and then only you're going to get an interview. It's not based on the internship. It's based on the skill set in your resume. Assume that you did a internship in a top companies. Okay, like you did in Honeywell, for example. Okay, and that's not going to guarantee you an interview call actually. Okay, if your interview in a call is purely based on your skill set in resume, because the tool, I mean, interview screening, sorry, resume screening is done automatically. Okay, so the tool will only look at the skill set that's in the resume. So your skill sets are more important. Okay. See, you do project in a company, or you do yourself. It doesn't matter actually. You can do a project in your college. You can work on an FPGA board, okay, or you can do in a company. It doesn't make any difference as such actually. Please, and see, only the difference what you are getting is that sometime when you do a project in a company, they may absorb you. Okay, but that too the chance is not so high, maybe say like a 5% chance you have in that. Okay, so I mean it's see only the thing you need to focus is to learn the skill set that is needed in the industry, and that is only going to help you in industry. You do say in for example you're in internship or project in US for example, and that is not guaranteeing to get a job. If you don't have good technical skills in your resume, nobody will call you for an interview. Your resume will not get shortlisted. Please understand this thing. Okay, the skill set in your resume, that is only going to help to get an interview call. It's not where you do internship, where you do project, that doesn't matter actually. Okay, so the skill set are the basic things actually. Okay, no, no, no. See, doing course in embedded or VLSI, it's up to you. You have to choose actually. You have to decide your field. You cannot, keep your leg on two boards simultaneously. Okay, it's like that actually. You can choose only one field. Please understand, VLSI is altogether a different field. Embedded is a different field. In embedded, you have a software and hardware. So you have to decide what you want to do. Whether you want to go in software or hardware, or you want to go in IC design. That based on your knowledge and skills, you have to decide. Okay, you can't choose both. Beneficial means it's on your knowledge. If you are not good in technical, you won't get job in VLSI design, even if you do a course also. Please understand, it's the toughest job to get. Okay, toughest job to get and toughest to survive also. It's not so easy. Okay, please understand this. Because so first you do assess yourself whether you have the suitable skill set and knowledge to go in VLSI design. Okay, so you choose your domain based on that. Okay, so both are good actually. I mean, all type of jobs are good. You have to assess whether you're good or not. Okay. See, for electrical engineers also, they can go in hardware or software. It doesn't matter actually. See, in industry, always consider the person's knowledge actually. See, when you say in hardware, typically we consider electrical or instrumentation or control, electronics and communication, or electronics and instrumentation. All of them are considered as a single branch actually. Okay, so you have to decide what you want to do. So hardware skills, I told you clearly, you should have very good knowledge on DSP, FPGA, and processor. You should know communication protocols, and you should also have a in-depth knowledge on the basics of all the components actually. So then only you're going to get a job. Okay, no, no, see, programming language depending on the domain, I'm telling you, don't worry on programming language, nothing actually for getting job. Please understand that you should know the technology. Okay, I mean, you want to work in embedded system, you should know processor, DSP, and FPGA. That's a basic requirement. You should have good knowledge in signal processing. You should have good knowledge in electronic circuits actually. Otherwise, you won't get even job actually there. So if you know C or C++ is good enough actually. Okay. So don't focus on the language, focus on the basics and the technology. Okay. And then the language is just the tool to implement it. Okay. And you may use assembly language depending on the type of project actually. Okay. Or in a mix of a C and assembly language. It all depending on company to company and the application. Okay. No, no, you see, whether you are in MTech or PhD or a BTech, the interview will be similar way actually. Okay, so what we ask is that we'll ask you one is on your resume, whatever skill set you have done in your resume, okay, and then we will ask you the question based on your objective. Okay, say suppose you are attending as a fresher in an interview. See, you have done a VLSI and embedded for example, so you could go in different domain. You could work in VLSI, or you could be an embedded software engineer, you could work in signal processing, or you could be a hardware engineer, right? So we'll ask you the objective, and based on that we will ask you the questions. Okay, if you are see, you're interested in working in say like embedded software, we'll ask you a lot of questions on electronics. It's exactly like the interview will be similar actually. You'll be joining at senior level. Okay, but the interview will be exactly similar actually. So there is nothing as such. So you have to have a clear idea on what you want to do. I mean, in which domain you want to go. Then we'll ask you to draw a lot of circuits. I mean, ask you to draw a lot of calculations and so on actually. We'll ask you to, you'll have a quite tough interview actually if you want to work on that actually. If your aim is to work on embedded software, then I told you they'll ask you a lot of questions on FPGA, DSP process, electronic circuits, then a bit on DSPs and algorithms, and sometimes they'll ask you to write, and if it is software, and maybe will ask you to write some programs actually. Okay, so anyone now, see, nobody will ask you specifically you need to write in Java or something like that. They will tell you any language of your choice. See, in interview, we assess your technical skills. We are not keen that whether you know not 10 languages. We in any one language, if you can write, that's good enough actually. Okay, please understand that C language is used in every embedded system, for example. Okay, so if you know C, that's good enough actually. So we'll ask you a lot of questions. So you need to be very clear what you want to do, because you have to clearly state that in your interview. Because when you apply as a fresher, for example, they could consider you in multiple roles. But if you are in VLSI domain, you have to clearly say that I'm interested in VLSI domain. Then the interview question will be purely on that actually. Okay, so you have to clearly state that in your resume. You have to have a clear, objective in your resume. So that will help the interviewer also to ask questions, because we will ask you the questions based on your interest actually. Okay, because we have to see like how good you are in that particular domain, then we will decide whether to recruit you or not. Okay, so I hope it answers you. No, it is you are absolutely wrong. Actually, industry is not software driven, because you have not really searched the industry. Please understand one thing. See, you are using the software, but you are working on hardware. You have to implement those software in the hardware. As I told you, in the cloud, it's based on say high-end DSP processor or an FPGA or a high-end processor, or it's combination of all that. To develop a software, you need to know the architecture of a processor. Without hardware, there is no software. Please understand this thing. You're only aware of IT companies. There are a lot of companies. Please Google it. You'll get a lot of information on that. Okay. See, it says in server also, in a product, you take a mobile phone, you have high-end ARM processors, right? Or different GPUs and other things, right? There is no server there. In server also, it's a processor at the end, or a DSP or an FPGA. Okay. So there are a lot of opportunities actually. I'm in the industry since the last 19 years, and I'm quite well aware of the industry trend in India and abroad actually. You just Google it, you'll get the answer. Okay. So you have to decide what you want to work, and not just by reading something. Don't run behind that actually. The core domain has always the opportunity, and it's a long lasting career actually. Okay, it's not like IT software domain where your career is just 10 years, and then you don't have much scope. It's not like that. Okay. uh, No, no, be it like a project, you can see, choose the field based on your interest, I'm telling you. Say, for example, you can do project in DSPs, or, then some signal processing, or any, say, control, or, say, any IoT based application, anything you can do, or any machine learning based or anything. But few things you need to consider. One is that, the platform where you implement, that's very important. So you should implement in a platform that's used in industry. Say, like either you implement in a DSP or a processor and FPGA. That's number one. Number two, in your project, you should have multiple things involved. For example, when you're doing a project in any domain, so you may have to interface certain sensors, or you may have to acquire data from certain devices using various communication protocols. Okay, by doing that, you'll be learning about these protocols. Okay, because that's very important. So you need to know I2C or SPA, or you need to be able to communicate through CAN and so on actually. So you need to have many different type of devices, or the interfaces in your product, so that you get a chance to learn that. That's the second thing. And the third thing is that you need to also implement something which is which important technology actually. For example, you do something in signal processing, so you could use some machine learning algorithms or AI algorithms, something like that, when you do segmentation or something like that actually. So you can use that actually, so that will add a good value actually to your project. That's very important. Okay. So you have to, see, hardware. I told you, either you do it in a processor, DSP, or an FPGA. Okay, and then you can do a data transfer. So you can say transfer the data to a mobile phone, for example, if you have a Wi-Fi module, or you could transfer to a PC, and then you could do some processing there. So both you could do. It's up to you actually. So the best thing is that you search some IEEE papers, and consult with your project guide, and choose the domain accordingly. And again, you can choose the domain based on your interest. Okay, but please ensure a few things. You have to implement it in a platform that is used in industry. Number one. Number two, you need to have multiple technologies involved in that actually. So that will really help you actually. Okay. See, learning architecture processor means, you need to understand, what are the building blocks of the processor, what are the functions of each of them, how a register is constructed, and how to use them actually when you develop. If you want to be in embedded software, you need to know how to develop a software actually, in using all of the things actually. So that is what is the architecture. So you can go through, any of the processor architecture, the user manuals, or any of the books actually, and you can learn that actually. You need to know, because in interview will be asking you to draw block diagram process, and ask you to explain certain blocks actually. So you should be able to answer that. This is a common question in any interview. Okay. No. Knowledge in MATLAB is not important to get in a VLSI domain. VLSI domain, you need to have a good knowledge in in a component semiconductor physics, and also analog design, and also digital, and also HDL, and so on. MATLAB is not required. MATLAB is for software. Software means either signal processing, or machine learning, or embedded software. Okay, it's not required. No, Python is not that much useful. Okay, because Python is in a why I told Python in a VLSI, it is for a scripting actually. Mainly for verification. You have to understand one thing. As a fresher, you don't know in which domain in VLSI domain you'll be working, because when a company hire you, they may consider you for a front-end designer. If you're a designer, you will never use a Python actually. It's for a verification engineer. It's not for a design engineer. But you can learn Python, but it's not mandatory. Okay, if you know, for example, C, that is good enough actually, because nobody will reject you for that reason actually. They will see how good you are in one particular language. That's what we look actually. So in interview, what we do, for example, if you are interviewing for embedded software engineer, we'd ask you, okay, you write a code in any language of your choice. We will not tell you write in Python or Java. So that's what I'm telling you. They will tell you, okay, you have a processor and you have to do certain things, and so write a code in any language of your choice. Okay. No. To become a testing engineer, you need to see quality engineer. You don't need to do anything really. I mean, you need not really need to have anything. You should have very good communication skills. So, see, typically, what happens is that quality engineers, are, there's someone who don't have that much technical knowledge. Okay, so companies will put generally there. Okay, and that is not that complex job also. So you can, it's bit a sort of a relaxed job, you can say. Okay, it's not like R&D where it's bit stressful and all. Okay, but typically to become a testing engineer, you need to have very good software knowledge, and I mean programming languages or LabVIEW and so on. And if it is an embedded software, and you should have generally good knowledge on the hardware as well. Okay. No. You see, if you are choosing say particular language, you need to have a proper reason actually. Say for example, you are using C, you should have a reason for it. So you should be able to convince him actually why you have chosen it actually. So it could be say like maybe your code composer studio may support it or something like that. You can answer, or you can say like I mean if you do programming in that particular language, that is fine actually for that application. See, if you do typically assembly language programming where you need a critical performance, or you need a lesser execution time and other things actually. So you could answer that actually. No. But see, there is no hardware project as such alone, right? In a hardware, to work a hardware, you need a software, right? It's a combination. When you say in FPGA also, the HDL, it's called as a typically hardware, but HDL is actually a programming language, right? Hardware description language, right? So you need to have some software actually in a project at least. But you can choose your career in hardware domain. That's fine. But without say hardware, it is very difficult to do a project, right? I mean, otherwise you have to do something in VLSI design. So that is not so easy as well. You need to have the tools and other things, right? Okay. No. Sample resume, you need to have a, see, for a fresher, typically your college will be having a sample resume, but in your sample resume, ideally you should have a objective, okay, and then you should have the skill set, okay. So the skill set means, what I've told you actually in the session. So you need to have them in your resume. Otherwise, your resumes will not get shortlisted. Please understand, okay. Okay, so that's very important. Okay, and also we know the paper you have published, the projects you have done, the training you have attended, the internship you have done, all of the things you can add actually, and you can add also something on, I mean the hobbies and other things actually. Okay. See, Artos, you can say, I mean, learn also actually. So there are a lot of books and all online sources and all, or even you can do certain courses. I think you'll be studying Artos also in embedded system, right? So you can learn one of the Artos. So if you want to be a software engineer, that is required actually. Okay. No. Embedded training, you have to decide what you want to do in embedded system. Say in embedded system, you have a hardware and software. For software, I mean, or hardware, you can do it in NILT in Calicut. That's good. Or you can go to Bangalore and do. I mean, they have a lot of institutes actually. In NILT in Calicut is also quite good. I think even they have a good placement actually. Okay. So training in centers, it is depending on your domain actually. So for example, you want to do Singapore's in training, Bangalore is the only place where you get some training. Okay. So VLSI design, you say front end you can do in CDAC or NILT or ERNDC. But if you want to go for back end, you need to go to Bangalore actually. I don't think anywhere in Kerala you have such trainings actually. Okay. So it's very important. So first you decide your domain, what you want to do, and then you have next is you have to choose the training center. When you choose your training center, you please go through the course content. That is very important. And second thing, you also see what are the tools and software available there. Actually, that's very important. Okay. So if somebody is teaching you 8051 in embedded, it's not worth to do that course. So, ideally they should teach you on ARM processor, then on RTOS and other things actually. That's very important. So it's very important for you to choose the go through the course content, because that is going to help you to decide your the training center and other things actually. And again to choose it based on your career objective and goal. Okay, so these are the important thing actually. You need to consider. Okay, so first is the objective. That's the most important thing. Decide what you want to do, and only you have three fields in the core domain. Either it can be a software or hardware or VLSI. VLSI is altogether different domain. In software it can be embedded software or a DSP, or in hardware it's pure hardware design. Okay, so A and ML it's a technology, but it is part of embedded system, and so it's used in signal and image processing. Okay, so to work in software you need to know A and ML and IoTs. These are mandatory things actually. Okay, so any more questions? Or if somebody want to ask me directly, they can unmute and ask me. It's fine for me. Or if you're not clear on certain things, you can even ask me that. Okay. Yeah, I will send the presentation to Dr. Arun. Okay. So any more questions on higher studies or projects? I mean, or different type of jobs. Okay. So R&D is not the only job. You have different roles like sales, marketing, procurement, quality, regulatory. I mean, you could choose anything of your based on your interest. Huh? So R&D is not easy job. Please understand this. It's really challenging. One is to get difficult to get, difficult to work, and difficult to survey because you need to have very good knowledge. You need to be ready to learn always. So there's no shortcut there. Please understand this. Huh? Because many time what happens, people join in R&D and later they move to different domain because they can't bear that pressure and the challenges. So you should be ready not to take the challenges. So you should have that mentality. Okay. No, higher studies is good actually. As I told you, if you want to work in R&D, it's always good to do and a masters. Okay, you can do it in India or abroad based on your interest. Okay, I mean even masters in India is also good. But if you want to do masters in abroad, you need to really do a study actually of that particular country, the job availability, and you should have good financial background as well, because I mean you have to spend a lot of money initially actually, because scholarship you may get, but still, so you should have that actually. So that's very important. No, country, you have a opportunity in every country. For example, see, electronics is a vast field, as I told you. You can work anything there, right? Communication. See, if you see in Europe, you can say a lot of communication companies are there, say in Scandinavia, I mean, say Sweden or Finland. If you want to work in Singapore, a lot of companies are there in Denmark. I mean, in France, Netherlands, in Germany, a lot of automotive companies are there, in robotics companies are there in Germany, for example. So you can, consider. But as a fresher, you won't get job in abroad. You need to have experience, at least 4 years of experience to get a job in abroad. Okay, freshers will not get a job in abroad. So that's the reason why many students are going abroad for master's degree, because once you do master's degree, you have good knowledge, you will get a job there. Okay, so that's very important. Or doing masters in abroad is good if you want to do PhD, because you get a chance to work with the professors and you get a lot of funding options in abroad actually. It's not like India there, and you could even do a postdoc and all after that actually. So I mean, if your interest is to really work in academics and research, then it's good to do masters in abroad. Okay, because you really get a lot of exposure, and I mean you get a lot of chance to work with a lot of people and all actually. Okay, because you don't have such institute in India. Even IIT, so we now want to have such facilities actually, for example. Okay. Yes, VLSI, there are a lot of companies. You have almost all VLSI, I mean, IC design companies in it. Almost 90% of them, most of them in Bangalore, some in Pune, Hyderabad, Chennai, and so on, actually. Even in Kochi or VVDN or, this thing actually. Wipro, they work in VLSI domain. It's good, but it's difficult to get there. I mean, so you need to really prepare, need to have very good basic knowledge and all that. Then you can get, okay. No, no, internship you can see do anywhere. I mean, as I told you, you can do it in manufacturing. You can do it anywhere actually. I mean, you see in whichever domain you do it internship in a manufacturing, or for example, you do an internship in a mobile, repair shop or a television repair shop. Still, you will learn a lot of things. See, to design a product, you need to know multiple things, right? Because then only you will be able to design a good product, right? That's what you learn when you are working in a product company, because you work with a lot of people. You will understand, what are the difficulties, what are the expectations there, and so on. Okay. No, no, no. See, you can find. I mean, I can't say like which university is good in US, etc. But you can search actually. I mean, a lot of times ranking and other things there. That is just for a reference only. But what you need to do really is that you need to go through the university website, see the professor's qualification and what all, of tools they have, what all facility they have, and how their collaboration with other, institutes and industries, etc. Okay. Even you have many good universities in Europe also for biomedical. I mean, US is not the only place, and US getting visa is quite difficult now. I mean, you could even consider in Europe. I mean, see, Europe, you have a lot of medical companies like Philips is in Netherlands, or in Siemens is in Germany. I mean, you have plenty of them, right? Okay. So you could search as you need to see like what are the facility they have, how is their research collaboration, what are the tools they have, and other things. So then you choose actually. Okay. Any more questions? So I'm fine to have some more time because it's a weekend for me, so I don't have any issues. If you have questions, you feel free to ask. Okay. So this
Sir,
session
there
is
are some questions.
yeah, yeah. Please feel free, no problem. Okay. Yes, development board definitely will ask you because why we will ask you is that because we should know. I mean, what all the why you have selected particular evaluation board because it's a important question for any project in any industry when you are designing anything you will have select a component. When for example even when you are selecting a resistor you need to consider certain things. So that is what why we need a good basic skills. Okay, so in case of a development board we'll ask a question why you have selected the development board, so you should able to answer that because it's one is like based on your project requirement. Okay, because the development board supported the processor, power is sufficient enough. I mean, and also it has enough memory and it has different type of interfaces, for your project. No, those should be the answer. You should never say that it was available in my college, it was cheap, that's the reason I've selected. No, that's not the answer. That you can tell that as one of the factor you have considered, but that is not a major factor. Okay, so you should say like this process has this, that's you should we'll ask you to draw the block diagram of the evaluation board. That's a normal question asked in any interview. You should able to explain the evaluation board. You should able to know, clearly tell the different modules used, the purpose of each of the modules, and so on actually. So they when you say like there is a DDR2 memory, they will ask you about DDR2 memory. What is the difference between DDR2 memory and SRAM and so on. So you should be able to answer that. That's what I told you. The success rate in an technical interview is 20%. Okay, and this is how we reject a student actually. Okay, not we, any company actually. Okay, so you need to really study that. That's what the expectation actually from you. So you should able to tell why we are used, and you should really study the block diagram of the evaluation board, and that should also should be in your project report ideally. Yeah? Because this is what I normally tell when I do external examiner exam for BTech or MTech students actually. So you need to have that actually. You need to study that. You should have a say few paragraphs written in your even in your project report. Why you have selected the module. Okay, you should have a proper justification and reason actually. Okay, so that's how you're doing a design in a company actually. Even when you are selecting a programming language, there will be always a reason for it actually. Okay. No, no. See, to work in say testing, you need to have a good knowledge on the software actually, and also hardware because and also hardware, and also you should have good knowledge on the tools actually. For example, you should know how to use an oscilloscope, how to do a lot of measurements there. You should be able to generate a different type of signals using a function generator or arbitrary waveform generator, etc. Because you need to know the tools actually. Because so that's very important. Okay, so we'll ask you a lot of questions on the tools also because you need to develop a automation setup to get the data from an oscilloscope and plot in, maybe in an Excel sheet or something like that, right? I mean, so also you need to have good knowledge on a lab view and all because you do a lot of automation setup. Okay, that's the general requirement. Okay. See, I mean, for this microcontroller, it all depends actually. I mean, see, like Raspberry Pi is quite good board. Okay, if you want to work on that, but again, it depending on your application.
Sir,
Uh, yes, please.
sir,
Okay, so
what
it's
are
up.
the softwares required for electrical engineers in the recent trending, sir?
See, there is, you don't focus on the software. I'm telling you, need to have a decide what you want to do and focus on the technology there. If you know C or C++, that is more than enough. Nobody's asking you to learn other languages. Okay. So nobody really bothers all these things. It's your basic knowledge, and if you, that's what I'm repeatedly telling you. In interview, will ask you to write code in any of your choice of language. It's not a one particular language, because if you know one language, see, okay, for example, thoroughly, you can learn other language. If you have to understand one thing, if you work in an industry, okay, when you have a say 10, 20 years experience, you will be knowing so many languages. You will be knowing the assembly language for multiple processors or DSP, right? Because you have to learn. If you know one for doing certain projects, you have to learn the language. That's how industry works, right? So you need not focus on that. If you know C, that's more than enough. You need to have good basic knowledge. That's more important. Okay. So my question to microprocessor. So my ARM processor is very popular. So you could consider Raspberry Pi, because it's a nice processor with a lot of good interface. Because Arduino board is not worth really, yeah, because it's used a very low end FP, I mean a processor and all. It's not that much useful actually. So I won't recommend you to use that. You could also use a DSP and FPGA, because again it's an embedded system, part of embedded system. So you need to have experience in that. That's mandatory if you want to work in get a job in core domain. Okay. Yes, GATE is a mandatory requirement, to get admission in MTech. Without GATE, you won't get admission to MTech in good colleges. You need to have over 90% of the score, because GATE has got other advantages also. One is you get admission to MTech. Second is that you get chance to work in government organizations like ISRO, DRDO, and so on, because they do consider GATE score. And the third thing is that when you prepare for GATE exam, you need to refresh your basics. Okay, so that means it'll improve your basic knowledge, and that will help you to get a job in core domain. Okay, so three advantages. Okay, you can search my name actually, you'll find it. Any more questions?
Sir, your email ID, sir.
Email ID, no, see, you search my name in LinkedIn, you will get all those things actually. Okay. And see, interesting project again, depending on your field of interest. But still, I would say, like, if you can do something on signal and image processing and implement it in a DSP or an FPGA, will be really good actually. Something you can do, maybe on say some object detection, and so then control of that, so something on machine vision. So those are really good actually, because many students really don't work. Sometimes students just develop it in a MATLAB, okay, and that's where they stop it. But you could implement it in a DSP or in a FPGA board. I mean, you could get a user maybe a laptop camera, and get these signals directly to a DSP or an FPGA, and you can do some processing. Then maybe you can do some compression and you can translate, something like that you can do. Or maybe you can use some of the AR ML technique, in segmentation and other things. Okay, something you can do that kind. But you can find a lot of papers in IEEE site, I mean latest papers, and you could do some project based on that. Okay. No, no. See, telecommunication domain is there, but again, I'm telling you, in telecommunication also, you have got a different type of jobs. Please understand, you have only three type of jobs in industry. Telecommunication, you say, you have a lot of companies in India like Alcatel, Lucent, or I mean, Cisco or Qualcomm. No, anything you name it is there in India. Okay, so I mean, if you say, take the example of say Cisco, for example, in they do a lot of activities. Say they develop telecommunication hardware, they develop telecommunication software. When you say software, they develop a lot of communication algorithms. Also they develop a lot of signal processing algorithms. Telecommunication is basically signal processing based, right? So you have to decide what you want to do, whether you want to be a hardware engineer there, or you want to be a engineer who is working on communication algorithm development, or somebody who is working on the signal processing aspect of it actually. So you have to define that actually, because it's a very very vast field. Please understand this. Or you could be a service engineer, or you could be a manufacturing engineer, for example, anything. Okay, so you have to choose actually. Or you could be working on an ASIC development for communication. For example, Cisco has got R&D in Bangalore. They do develop a lot of processor ASICs and other things there, right? So it's all for different communication applications actually. Okay, so you need to have a clear objective actually, because otherwise you can't, because it's so vast actually. Telecommunication, any domain you take, it's very vast actually. Telecommunication, it's vast. Or you take it generally electronics, it's vast. So you have to be very specific. Okay, even you work 30 years in industry, you can't learn everything actually. For example, a PhD won't learn everything, right? You work on only a certain domain. It's so vast field, so you can't learn everything. So you have to select a field and focus on that actually. When you say hardware, you may be working implementing it in a DSP processor and FPGA. Okay, same way maybe you develop an algorithm, it may be implemented in any of the platforms, or you may be developing an ASIC like that. Okay, so you be very clear on what you want to do. Okay, so either decide whether you want to be in software or hardware, and one or in IC design, or if when you say software, you clearly decide what you want to do there. Do you want to work on signal processing part, or do you want to work in communication protocol development? You decide that actually, and then focus, learn on that domain, because you should have a clear objective, because in interview they will ask you this question, and you should be very clear on what you want to do. Okay, so then the interview will be easy for you as well. For us also it is easy, and for you as well actually, because then you can focus on that, and you can easily clear an interview. Okay, that's very important. Okay, no, you see, as I told you, signal processing you can implement it in a MATLAB also, right? That is also fine. There's no problem, but it's always good to implement it in a DSP and a processor, because typically most of the people implement it in a MATLAB. Okay, yeah, MATLAB is used in industry, but when you implement it in a DSP and processor, it's even more better. Okay, so that way, or you can implement AI or machine learning algorithms. That's also fine. You can do it in MATLAB or even Python. That's also fine. But when you implement it in a hardware, it is much more beneficial, because industry will give a huge value to that. Okay. Okay. Any more questions? No, my name is Renjith CV. You can search it, you will find. Okay. Any more questions?
Sir,
Yeah, please.
sir, actually, I asked in chat and my call got cut. So, can you repeat the answer for like if the
We,
project was done on software, is there any problem?
there is no problem actually. See, when you say software, you could develop an AI or ML algorithms, or you could develop some signal processing or image processing algorithm. There is no problem. Actually, you can get job. But see, if you're a BTech student, you're not the only person in your project. You're a team of say 3 or 4 students, right? So you could so you initially develop in MATLAB, and then you could implement it in a DSP or FPGA. That's what I want to say. So that will be more beneficial actually, because in your interview we'll always see which hardware platform you work actually. I mean, that will give you an edge actually, to you to compare to others. Okay, so you should always prefer that. It's okay to do in both obviously. I mean, that's also fine actually. But always try to do, because you are a team of 3 or 4 people, so you can split your team. Somebody work on this and somebody work on the other actually. So that's how I did my during my engineering, because my professor insisted me to use a DSP process C50. I mean, almost 21 years back actually. So he forces to do actually. So so you can do that way actually. Two of you do in a MATLAB, same thing you implement in say FPGA, and you could do some comparison or something like that actually. That way is better. Okay.
Okay, thank you.